Hello there, and welcome to the planet's memory, where curiosity lingers like evening light and every question has time to unfold. Tonight, we are not in any hurry. This is a space where thought drifts at its own steady pace, where silence is not empty but filled with echoes waiting to be noticed. And I'd like to begin with a question, one that almost feels like a bedtime secret each of us has whispered to ourselves at some point. What if the very air around us remembers everything? Not just the winds and storms we feel upon our skin today, but oceans that once drowned continents, forests that turned quietly into coal, climates so fragile that entire worlds of creatures relied on a single balance. What if breath itself is memory? If you pause for just a moment right now and take in a slow breath, that air didn't begin with you. The molecules flowing into your lungs tonight may be unimaginably old. A fragment of oxygen first freed by an ancient cyanobacterium drifting in shallow seas 3 billion years ago. A whisper of nitrogen exhaled by a forest that no longer exists, its roots deep then, but now turned into stone. Even a trace of water vapor rising from an ocean that once lay in a different place on the globe, shifted by continents moving as if in slow sleep. Each inhale is a gentle inheritance, an intimate brush with the past. And when you let it out, you give something back, a contribution folded into this ongoing archive of breath. Scientists call these traces isotopic signatures, tiny differences in the weight of atoms that act like diaries of deep time. Buried inside ice cores, trapped within bubbles of frozen atmosphere more than 800,000 years old, they offer us a way of listening to climates and events long beyond memory. When volcanoes blackened the sky, their sulfur left marks. When oceans withdrew and reappeared, their carbon cycle left patterns faint but permanent. Every event leaves its record, subtle but indelible, stitched invisibly into the air itself. And so we begin to see that the air is not empty. It is not merely background. It is a great, restless witness. And yet, air is also fragile, always shifting, never fixed, impossible to hold. You can cup your hands and try, but it will slip away, reminding us that memory does not need solidity. Memory can be vapor, can be mist, can be something that flows freely, shared among every creature that breathes. Perhaps this is why it feels haunting to think that you may breathe in the same atoms once breathed by an ichthyosaur gliding through the Triassic seas, or by a firekeeper tending embers 30,000 years ago. Breathing is intimate, but also endless. It leads both backward and forward, crossing the divides of time. We might wonder, then, how much of the planet's memory has already disappeared, recycled into silence. When tectonic plates sink beneath each other, ocean crust and atmosphere are swallowed into the Earth's mantle, erased from the surface but not from existence. What becomes of that memory deep inside, buried beyond reach? Does the Earth itself remember what the atmosphere has forgotten? Does the slow churn of entropy not so much destroy history as scatter it, waiting for us to patiently read the fragments? This thought draws us to extinction, to eras when entire lineages vanished, leaving not only bones but absences in the chemistry of the air. When life ends, breath changes, oxygen falls, carbon grows heavy, the air shifts into something new, and though the creatures themselves are gone, the sky above them carries the record onward. Silence written into gases instead of stone. Could it be that every extinction is not just an ending but a rewriting of atmosphere, a silent echo that never fully disappears? Perhaps this is what connects us so deeply to the idea of the air as memory. It is everywhere around us, invisible yet constant, intimate yet universal. It blurs the line between the personal and the planetary. Each sigh, each storm, each volcanic plume is folded into a continuous diary that Earth has been writing since breath itself began. But diaries can fade. Pages can be torn. Entropy does its quiet work. And so we are left wondering, how much is still carried in the molecules drifting above us, and how much has already slipped into silence forever? And yet, if even air itself can carry a fragment of the past, if memory can float invisibly around us, then time may not be as distant as it feels. Which makes us wonder, what other traces of Earth's early story might still be waiting, quiet and unseen, sealed not in breath but in ice? a memory we could almost touch if we only knew how to listen. And so, if air itself can carry memory, if every breath is already an archive, then where do we find the oldest passages of this diary? We turn not to the stones at our feet this time, but to the deep, frozen vaults of the earth, where ice has been layering itself patiently, season after season, snowfall upon snowfall, compressing winters into crystals and silently preserving more than just cold. In these frozen cathedrals of time, air has been locked away, sealed into tiny glass-like bubbles, as if the earth chose, without intention, to bottle its breath for a future listener. When scientists drill into these ancient cores, pulling them up from kilometers below the surface, they are not only touching ice, but inhaling whispers of a sky that existed hundreds of thousands of years ago. Each core, slender and fragile, is a passport to time, a way of crossing thresholds we could never otherwise reach. Within them are isotopes of oxygen and hydrogen, their ratios shifting with the warmth and coolness of each past climate. Heavier isotopes lean toward times of heat, lighter ones toward ages of cold. A rhythm is revealed here, the pulse of glacial cycles, the rise and fall of ancient winters and summers. It is almost as if the planet itself had been breathing slowly, in and out, over spans that dwarf human comprehension. Imagine it for a moment. A fragment of air sealed in the ice of Antarctica was once part of an atmosphere breathed by stepping mammoths and woolly rhinos wandering grasslands now swallowed by snow. Another fragment might have brushed the wings of birds now extinct, or swirled through the warm, shallow seas of interglacial times. Frozen not just as archives of chemistry, but as echoes of vanished worlds. And when they are released, when a researcher in a faraway lab allows those tiny bubbles to crack open under careful instruments, the air escapes again, sometimes for the first time in hundreds of millennia. The past drifts, quite literally, into the present, folded invisibly into the room. Could it be that in moments like this, ancient winters and lost summers re-enter our lungs, mingling across epochs as though no time divides them at all? And yet, these isotopes, simple and almost weightless, do more than carry climate. They carry quiet testimony to sudden extremes. A volcanic winter buried under ash, a spike of carbon dioxide marking a shift in oceans, a thin veil of methane hinting at catastrophic releases. Each signature is delicate, but once read, it tells of thresholds crossed, of balances tipped. You realize then that deep time is not uniform. It is not a quiet drift but a series of fragile stabilities, always at risk of sudden change. Maybe memory itself is like this, steady, but broken by silences, losses, and shifts too vast to comprehend in the moment. The ice tells us this too, that warmth and cold alternate, that life adapts, collapses, regrows. The planet breathes with cycles much slower than ours, cycles written in molecules we can weigh but never truly feel. And so we find ourselves asking, how close are we now to another tipping point, another silent rewrite of air that future beings will one day uncover? What strange isotopic trails will they find? And will they draw the same questions, the same quiet astonishment at what has been lost and what has survived? Breath here is both evidence and mystery. It proves that the air can carry across ages, but it also humbles us with all that has slipped away unseen, all the warmth and silence rising and dissolving before ice had a chance to capture it. Perhaps memory is less about preservation and more about what lingers despite forgetting. Perhaps each core is only a glimpse into a song far longer than any we can recover. And if isotopes can tell us about the warmth and cold of our past, then they also invite us to wonder about the ages before ice, before bubbles, before snow could preserve anything at all. What memories of Earth vanish completely when there is no archive but stone, water, and sky? And might we learn to read them not in ice, but in the very oxygen itself, the next chapter in our search for the breath of deep time? And if isotopes inside ice can tell us of the Earth's quiet breathing, then they lead us even further back, toward a time when the very air itself was not what it is today. There was an age when the sky was different, when the familiar atmosphere we take so easily into our lungs would have been poison, when the very act of breathing as we know it was not yet possible. Scientists call it the Great Oxidation Event, but that phrase barely captures what truly happened. Imagine a planet inhaling for the first time, exhaling life, remaking itself not with one sudden gesture but slowly, over tens of millions of years. It was not dramatic in pace, but in consequence. Chemistry turned into destiny, and destiny into silence and survival. Before it began, Earth's oceans were vast greenish basins, rich in iron and methane. A world where bacteria thrived in darkness and chemical energy was enough to sustain whole communities of life. The sky would have been tinted differently. Not the vast blue we know, but a dimmer, hazier veil spread across a surface heavy with gases unfit for us. Then, almost humbly, single-celled life began to release oxygen as waste. Tiny cyanobacteria floated in shallow waters, catching sunlight and splitting water molecules, releasing O2 that slipped unnoticed at first into an atmosphere where it had no place. For millions of years, this oxygen was captured by minerals, bonding with iron dissolved in the seas, rusting them red. Sedimentary layers of banded iron tell this story. Streaks of gray and red rocks stacked across the planet. A geological library of the Earth drowning in its own slow, rusting breath. But eventually, the minerals could not keep up. The oceans overflowed with oxygenated water, and the gas began to build in the sky itself. Imagine continents under weather that now carried something new, something reactive, something dangerous to all the life forms that had until then known only an oxygen-free world. Many of these early organisms could not tolerate the very molecules we treasure. Oxygen was destructive, corrosive, a radical intruder tearing through delicate bonds. Extinction swept across microbial dominions, silent and invisible, not caused by flame or flood, but by the invasion of a molecule filling every corner of their world. For them, the atmosphere became lethal. For others, it became a ladder to complexity, a doorway toward larger forms of life. What a paradox, that the same molecule that killed so much was the same one that would make us possible. Not because oxygen is gentle, but because it is restless. Its hunger for electrons fuels fire, drives metabolism, powers the machinery of cells that would one day walk, swim, dream, and wonder. Every breath we take is a reminder of that danger turned into life, of a chemical once feared that became the foundation of thought. Maybe every lungful we draw is an echo of that revolution, the sky still teaching us how delicate survival always is. And if we imagine standing in that time, a visitor traveling through epochs, we would feel the world slowly turning strange. Rivers carrying iron would fade. The rocks themselves changed color forever. Life that once ruled quietly in hidden niches dwindled, replaced by forms that could tolerate, then thrive, in oxygen's embrace. With more oxygen, new energies became possible, enabling multicellular structures, more intricate symbioses, more experiments in form. And yet, extinction walks beside creation. Each step forward means another left behind. Whole groups erased, others flourishing, and none of them knowing there had been a choice at all. Even entropy itself was transformed. Before oxygen, decay was slower, bound by sulfur and slower redox reactions. Afterwards, rot quickened. Dead things returned to soil with more urgency. Fire became possible on land, and atmosphere turned into both destroyer and preserver. Fire is the shadow of oxygen's promise. It burns forests, but it clears them too. Consumes, but it opens space for renewal. Could it be that every flicker of flame is a memory of that first atmospheric transformation? A living monument to a world's gasp for breath billions of years ago? And so we arrive back at the heart of it, the air itself learning how to live. This revolution was not a single moment but a long unfolding, a patient layering of change, almost invisible until the tipping point arrived and nothing was the same again. Atmosphere became a story written not only in chemistry but in loss and survival, extinction and possibility. It is humbling to remember that the very life we are, our thoughts, our dreams, still rests on the memory of that shift, the quiet upheaval when air was remade by life and life remade by air. And yet, if the air could once transform so completely, if the sky itself could turn from toxic to sustaining in the span of deep time, then we cannot help but wonder. How many more transformations wait, silent and unseen, already beginning their patient work? Does the air carry in its molecules the hints of the next revolution, one still too small for us to notice? And if so, when change comes again, Will it bring flourishing or silence? And if the air could once change so profoundly, filled with oxygen where none had been before, then what of the other voices that have always lingered in the sky? There is another element, quieter yet heavier, patient yet insistent: carbon. Unlike oxygen, which hungers and burns, carbon drifts. It does not vanish. It circulates, retreating from the air into stone, sinking into the ocean floor, rising back again through eruptions and decay. It is not silent, though. Carbon is a storyteller, a patient negotiator, a soft but endless voice through which the earth speaks with its own living skin. To understand carbon is to understand memory in matter. Long before us, ancient forests soaked in sunlight, drawing carbon from the air to build their trunks, their leaves, their silent labyrinths. When they fell, when they sank into wetlands and were buried beneath layers of sediment, their bodies became coal, their voices pressed into seams of rock like pages in a blackened library. In burning those seams now, we are not simply using fuel, but unlocking words written hundreds of millions of years ago. Every spark in a fire, every plume in a smokestack, is a ghost reciting text that once belonged to a carboniferous swamp. Could it be that each ember is a syllable of Earth's memory, released back into the sky after sleeping too long? Carbon speaks in other tongues too. Volcanic plumes, sudden and unignorable, carried carbon dioxide into the atmosphere during great eruptions of the past, shifting climates in ways that rewrote entire ecologies. When continents rift, when magma rises from deep mantles, carbon is exhaled, sometimes fast, sometimes slow, but always binding geology to life, atmosphere to stone. The fossil record shows us worlds where volcanoes drowned creatures not in lava but in air thickened with carbon's invisible weight. Extinction sometimes wears no face, no flame, but instead drifts silently as altered chemistry, tilting balances unseen. And yet carbon nourishes as much as it destroys. Plants listen to its abundance, growing thicker, faster, in ages where carbon was generous. In Earth's past, high-carbon atmospheres fueled dense jungles, dragonflies with wings the span of a hawk, amphibians large enough to shadow rivers. A different balance, another possibility. One might wonder, then, whether carbon is not enemy and not ally, but a mediator, shifting the script of existence according to its own cycles, impartial but never indifferent. The ocean is carbon's deepest diary. Much of it dissolves into waters, drawn under currents, circulated for centuries before being carried down into the abyss and trapped within limestone and marine fossils. Each shell of a foraminifera, each coral skeleton, writes with carbon, recording the chemistry of its ocean in crystalline detail. Later, long after those organisms crumble, geologists read their isotopes, their ratios of carbon-13 and carbon-12, finding the faint traces of ancient climates. The ocean speaks through shells, through isotope trails, giving us glimpses of warmth and collapse. Perhaps no other element speaks so clearly yet so cryptically. Cycles within cycles, memories nested within silence. But carbon has moods. Sometimes it lingers in balance, taken in by forests, given back by fire. Other times it escapes its bounds, rising sharply, destabilizing the climate itself. During the Paleocene-Eocene thermal maximum, carbon leaked catastrophically, likely from methane hydrates or volcanic vents, sending the world into a hothouse, melting poles, pushing forests deep into latitudes where snow no longer belonged. Life endured, adapted, shifted. Some vanished, others thrived. The record remains in sediments, in isotope ratios, in sudden warm layers of rock that whisper. Carbon once shouted. And here we find our rhythm again. Carbon cycles, retreats, returns. It is inhaled by green, exhaled by fire, drawn into oceans, pressed into stone, lifted again by mountain building, exhaled by volcanoes. Carbon shapes the tempo of deep time. Perhaps climate itself could be thought of as music, and carbon the conductor, adjusting pace, shifting volume, sometimes in whispers, sometimes in crescendos. Maybe it is not too strange to say Earth negotiates with carbon, finds its balance or loses it, teeters between flourishing and collapse depending upon the weight of its invisible hand. And when we look around today, at smokestacks or tailpipes, at fires and cleared forests, perhaps what unsettles us most is not that carbon is present, but that it is speaking far louder than before. Maybe we are amplifying its voice in ways the planet has not heard in millions of years. Not because carbon chose to, but because we opened those libraries of coal and oil and let the pages turn too quickly. And yet, the cycle does not end. Carbon will circulate long after us, drifting into new stones, new oceans, new forests we cannot yet imagine. So we close this chapter listening not just to carbon's past, but to its murmurs in the present, knowing they will carry forward, etched into isotopes, into shells, into every burning branch and stored breath. And if carbon could speak this loudly once before, reshaping oceans, calling forth forests, erasing worlds, then it leaves us to wonder, what happens when its voice grows louder still? And if carbon's voice has the power to tilt the balance of oceans, forests, and fire, then we must also listen to the moments when that balance was broken entirely. Across deep time, there have been intervals when the atmosphere turned dangerous, not by roar or flame, but by chemistry and silence, by gases accumulating invisibly until they remade the very conditions of life. These were times when the air itself became a predator, an unseen force shifting from subtle breath to sudden executioner. Extinctions are remembered not just in bone and fossil, but in the sky above them, in the invisible scripts of carbon dioxide, methane, and sulfur that tipped entire worlds into stillness. Imagine standing on Earth during the Permian some 252 million years ago, an age when volcanic provinces stretched wider than the landscapes of nations. The Siberian traps bled lava for hundreds of thousands of years, pouring out basalt, but more insidiously exhaling gases, carbon dioxide in volumes that thicken the atmosphere, warming the oceans to suffocation. Methane, too, may have burst from melting hydrates, accelerating collapse. Oxygen in the seas dwindled until waters turned stagnant, toxic in places where only bacteria could survive. Coral reefs withered, forests thinned, entire lineages of creatures vanished. Geology remembers it as the Great Dying. Life lost 9 out of every 10 species. And though the rock record gives us fossils, it is the air itself that tells us how suffocation truly spread. The enemy was not visible. The predator was breath. Not all extinctions arrive with fire and flood. Sometimes silence follows chemistry. Dust veils block sunlight. Volcanic ash falls across continents, blanketing rivers and deflecting warmth away until even photosynthesis falters. Sudden warming or cooling can ripple through currents, disrupting migrations, collapsing food chains from plankton upward. Lost atmospheres are measured today by their isotopic scars, carbon ratios shifted, oxygen signals weakened, the faint coated residue of imbalance. To hold an ice core or a limestone layer is to touch extinction, not through the bones of the dead, but through the gases of the living world that struggled to persist. And yet, in the stillness that follows such endings, something paradoxical begins. Evolution stirs in the silence. New lineages emerge from what little remains. Dinosaurs thrived in part because of the silence that followed the Triassic extinction. Mammals expanded into niches left behind after the great asteroid at the end of the Cretaceous. Silence, it seems, does not only erase, it also opens space. Could it be that extinction is not only an end, but also a rearrangement of breath, a pause in which the earth deeply inhales before it exhales again? What is haunting is that silence itself leaves almost no trace. Fossils are rare, atmospheres dissolve, ice preserves only so far. We are left with absences, with gaps in continuity that we try to fill with questions. Was it clouds of methane surging from the seabed? Was it dust darkening skies? Was it volcanic carbon released too fast? The atmosphere answers only in fragments, in whispers. But maybe extinction was not one event, not one signature, but the cumulative weight of breath turning against life. Not because the world intended harm, but because chemistry carries its own inevitabilities. And so, when we breathe today, surrounded by forests still living, oceans still alive with plankton, skies still filled with oxygen, perhaps we are closer than we realize to ghosts. Each inhale invokes species that are gone. Their breaths are not coming lead with ours. but the chemistry of their final struggles still shaped the air we live within. Extinction does not simply end a species. It edits atmosphere. It rewrites the composition of the living sky. Silence follows life into the air itself. Perhaps this is why the idea of extinction humbles us so deeply. It is not only about loss of form, of body, of movement, but about the emptiness that lingers in the invisible. Silence is not just absence but consequence. The stillness of fallen forests changes carbon levels. The collapse of plankton alters oxygen. Entropy writes its signature not only on stone, but in the very molecules we breathe. Life and air remain entwined, and when one vanishes, the other shifts endlessly in reply. And yet, if the atmosphere can remember the endings of entire worlds, if silence itself can seep into chemistry, what other traces remain hidden in the sky, waiting quietly, silently tied to eruptions and collapses that came long before us? And if silence itself can mark the ending of worlds, then the Earth also speaks in eruptions. Moments when the planet exhales abruptly, when the stillness breaks into a haze of ash and fire. Volcanoes are not just mountains. They are memories rising from the molten interior. They breathe with explosions that paint the sky in dust, clouding sunlight, cooling the ground, veiling entire seasons in shadows. Each eruption is a brief, fiery stanza in the long poetry of entropy. For though eruptions are sudden, their effects linger in ways both delicate and vast, folding themselves into climates, into lives, into the chemistry of air. Ash drifting in the wind is more than dust. It is pulverized stone, the shredded remnant of magma meeting atmosphere, scattered across oceans and continents. From Iceland to Indonesia, from the Andes to the Pacific Ring, volcanoes send these traces outward. Microscopic shards that, years later, may be found layered in ice or bound into seabeds like signatures of disruption. Each thin line of ash in a glacier or sediment core tells of a day when the Earth spoke loudly, and the world dimmed in reply. Could it be that each fragment is less debris and more a fossil of the sky itself, a brittle record of catastrophe folded into silence? Sulfur too rises from these exhalations, spreading thin veils through the stratosphere. Invisible to the eye, but powerful in effect, the aerosols scatter sunlight, cooling the planet by small degrees, sometimes enough to shift harvests, shorten summers, freeze winters in unusual places. Tambora, in 1815, turned the sky into a filter, bringing what became known as the year without summer, crops failing across hemispheres as the atmosphere held its veil for months. And yet this was not unique. Geology holds countless such events further back. Eruptions that have sent species starving, forests dying, oceans slowing. Some eruptions rearranged climates temporarily. Others pushed life closer to dissolution. But volcanoes are not only destroyers. They are creators too, exhaling not only ash but carbon, water vapor, elements that replenish the air and oceans. They birth new islands from fire, enrich soils with mineral wealth, awaken ecosystems that begin again on lava plains. We think of eruptions as endings, but just as often they are openings, worlds destroyed on one hand and seeded anew on the other. Perhaps this duality is the essence of volcanic memory. Not because volcanoes choose, but because entropy always creates as it erases. Still, the ash's journey is what lingers most hauntingly. To see great plumes rising 10 kilometers into the sky, scattering across continents, is to understand that a local event is never truly local. Dust and sulfur travel on winds, entering atmospheric rivers, drifting thousands of kilometers, circling the globe. And millennia later, when we cut into ice or walk cliffs of ancient rock, we find these layers still waiting. Thin, silent ribbons that tie faraway events together. A layer of ash in Greenland binding to an eruption in Alaska, another buried in Antarctic ice that began in a long-vanished caldera of the South Pacific. The planet, by scattering its ashes, stitched its histories into one. Eruptions are entropy in fast motion. Order broken into chaos. Stone turned into cloud. Silence burst into sound that circles the planet. But even entropy has beauty, and perhaps nowhere is it more visible than in the sight of twilight skies painted red from volcanic aerosols. Sunsets lasting longer, stranger, as light bends around particles. Painters in Europe in the 1800s captured those skies unknowingly, their works carrying the signature of tambura in pigments of unreal glow. In this way, volcanoes leave memory not only in stone and ice, but in our very imagination, in the colors we see, in the way history remembers the light itself. Perhaps ash is the most poetic of all geological records, because it is so delicate, so easily scattered, and yet so persistent. A single layer may be only a few millimeters thick, but it carries the memory of noise and fire, of suffocating skies and disrupted summers. To touch volcanic ash trapped in ice is to press fingers against a page of the planet's diary written in panic and breathlessness. And yet, if these thin veils of entropy can travel, and if they can linger across time, then maybe they mark not just endings, but the beginning of the Earth learning how to speak above silence. And still, one cannot help but wonder. If ashes falling from the sky can rewrite seasons, mute the sun, and paint memory into air and stone, what else might be carried invisibly in the wind? Unseen fragments of worlds undone, drifting until they find their place quietly in the record of time? And if ash can drift across skies, dimming suns and carrying memories of fire into the deep record of ice, then it is to the ice itself we must turn next. For it too is a keeper of memory, but not in days or centuries. It remembers in rhythms, in tidal pulses of cold and warmth spanning tens of thousands of years. Ice moves to cycles older than civilizations, older than species, older even than many of the continents in the shapes we know them. Glaciers advance, retreat, grow heavy and vast, then thin into meltwater that creeps back into the sea. They are the planet's slow breath, exhaling cold, inhaling warmth, changing the air in patterns so steady they could almost be mistaken for intention. Within their depths, ice cores speak in layers, each snowfall a pale sheet pressed into memory. Compressed by its own weight, it transforms into glass-like crystals where ancient air rests trapped within. Bubbles no larger than a grain of sand whisper of atmospheres long gone, of carbon dioxide concentrations swaying like tides, of oxygen isotopes shifting with global temperature. To drill into ice and look down its translucent length is to peer into a time machine, not of stone or fossil, but of air itself embalmed by cold. The gases remind us that climate is not a fixed stage, but a song of oscillations, verse followed by verse, each line building upon what came before. The great Milankovitch cycles, delicate tilts, wobbles, and distances in Earth's orbit, set the rhythm of these ice ages. Tiny changes in how sunlight touches the surface, almost imperceptible in any human span, accumulate until seas rise, then fall, until forests march forward, then shrink away. This is the patience of geology, where time itself carves landscapes not with violence, but with persistence. During glacial peaks, kilometers of ice covered what are now cities, rivers buried under frozen silence, mountain valleys carved into U-shapes. And then, when warmth returned, it was as though the world remembered its rivers, its forests, its wild green canopy, water rushing back, reorganizing life again. The air changes with each of these frozen rhythms. With more ice, carbon retreats into oceans, into soils, lowering in the atmosphere, thinning its warmth. With melting, carbon is released once more, escalating temperatures, speeding feedbacks. The glaciers and the air are partners in this dialogue, each responding to the other, each reshaping life not by intent, but by inevitability. Could it be that the air and the ice are not separate forces at all, but the two halves of a single long memory, one still solid, one still moving? And we, who live now, stand between. Our world rests in what scientists call an interglacial, a warmer breath, a pause in the ice's advance. This was the warmth that gave rise to agriculture, to settlements, to the entire span of history we think of as human. Every city, every story, every library depends on this brief, temperate lull in the greater frozen rhythm. Were we lucky, then, to be born inside this pause? Or is our whole existence simply a fraction of a longer cycle that will one day reclaim much of what we have built? Ice is never only frozen water. It is a recorder of chemistry, a sculptor of mountains, a carrier of silence. When glaciers retreat, They leave erratics. Massive boulders carted far from their birthplaces, dropped like punctuation marks across the land. They leave striations scratched into bedrock, subtle signatures saying, "We passed here once, we will come again." And in their meltwater they release nutrients ground from rock, streams carrying traces to coasts, feeding plankton blooms that in turn feed seas. Memory does not sit still in the ice, it flows outward, transcribed by rivers, translated into life. Perhaps most humbling of all is the realization that the echoes of ice are still with us, not locked in some distant past, but present in the foundations of our landscapes, the chemistry of our atmosphere, the migrations of species still adjusting to rhythms older than they are. We inherit not only the warmth but the haunting memory of the cold. Some of it lives in coral reefs, their banded growth recording shifts in sea levels. Some of it lives in isotopic anomalies buried in stalactites. Some of it lives in us in the migrations of our early kind, forced to move and change as glaciers grew, then withdrew. And so we are left listening. The ice remembers, the meltwater whispers, the air itself shifts to their rhythm. And if these frozen tides could so quietly overtake continents, could advance across forests and retreat again, then what other hidden oscillations shape the world around us? Cycles so wide and patient that we can barely sense them happening at all? And if the ice remembers in long silences of cold and warmth, then breath itself is the smaller echo, repeating not in epochs but in moments. Every inhale we take, every exhale, is a joining into that greater rhythm, the atmosphere folding us into its story. We hardly think of it, for breath feels immediate, ephemeral, gone the instant it leaves us. And yet, each breath carries weight, not of mass alone, but of memory. The molecules entering your lungs right now may have passed through thousands of beings before you. A single atom of oxygen could once have been carried by a fern when forests were young, then exhaled by a trilobite, dissolved in an ocean, released by a wave, and finally drawn by us, here and now. It might once have filled the chest of a mammoth, or brushed against the lips of someone who lit the very first fire. Breath is inheritance, invisible yet endlessly shared. Science reminds us that the atmosphere is a vast recycler. Molecules are broken, remade, exchanged, but they are not truly lost. The oxygen we draw comes largely from photosynthesis, from forests, algae, and great drifting blooms of plankton that cover the oceans. Carbon dioxide leaves us with each exhalation, only to be absorbed again, taken into leaves by sunlight, into corals by skeleton, into limestone by slow chemical patience. Tracers tell us that some molecules cycle quickly in years or decades, while others join the deeper turning wheel of subduction and volcanic release, becoming stone long before returning to the air. Perhaps this is why breath feels both fragile and eternal. It vanishes from us in seconds, yet it has been circulating for billions of years, forming a continuity beyond perception. But how curious to think that what we call my breath or your breath is never truly ours. We do not own it. We only borrow and return it as countless others have done before. Not because we are unimportant, but because life itself is porous, boundary, and self-blurred with atmosphere. You breathe, and in that act you join the company of whales in their slow surfacing plumes, of birds migrating tirelessly, of trees exhaling each dawn. It is communion without meeting, intimacy without recognition. Could it be that the air makes us all kin, binding every life across time into one extended breath, an inheritance that is always both ancient and new? And even extinction does not erase this cycle entirely. When a creature takes its last breath, its molecules disperse, their chemistry continuing the journey. Breath is never gone. It is carried onward into currents of wind, into cycles of decay, into new lungs and new leaves. Perhaps this is why memory feels heavier when we breathe quietly, as if in silence we can sense the persistence of all who came before folded invisibly into us. If air can carry death, it also carries presence. Think of how smells rise. Sulfur from volcanoes, salt from coasts, pine from forests. These are chemical letters in motion, moving with the air, shaping memory not only through geology but through feeling. When you inhale such traces, you also breathe in a fragment of place, a whisper of a process older than you. Even the trivial act of standing by water, pulling air across the senses, is to connect with something braided of yesterday, today, and tomorrow. And yet, no catalog could ever trace every molecule's path, every exchange across epochs. Maybe that is the wonder, that the intimacy of breathing is not in exact recognition, but in surrender. To understand that each breath is enough in itself, no matter where it has been, no matter where it will go. Like tides in miniature, we inhale, exhale, inhale again. An endless rhythm without origin or end. So when we speak of the weight of one breath, it is not its grams or molecules we mean. It is the inheritance, the invisible kinship, the reminder that every life before us has filled the atmosphere and altered it in ways that ripple still. Breath is continuity. Breath is memory. Breath is the earth reminding us that nothing is kept, but nothing is fully lost either. And so, as we breathe out now, returning our momentary share to the currents, the question arises with gentle inevitability. If even the smallest act of our bodies is entwined with prehistory and with futures yet unborn, then what else is moving unnoticed through the air? Rivers invisible, currents carrying life and dust across the planet, reshaping worlds in silence. And if every breath we take is an inheritance, mingling with molecules from countless lives before us, then it becomes clear that air itself does not stand still. It flows and moves, not quietly but endlessly, shifting not only breath but soil, pollen, seeds, and traces of life across distances so vast we can scarcely imagine them. Above us, invisible highways stretch across the globe, the great atmospheric currents. We cannot see them, we cannot hold them, but we live within them, carried by their constant tides. These are the invisible rivers of the sky. They flow not with water but with wind. They gather desert dust and carry it thousands of kilometers across oceans until red minerals fall softly into the Amazon, feeding rainforests far from the Sahara where the dust first rose. They bear grains of pollen from forests and scatter them across plains, ensuring that life does not stay confined, that continuity is scribbled into new soils. They sweep volcanic ash halfway around the world, covering places that never saw the eruption itself and leaving thin blankets of powdered memory for us to discover thousands of years later. Could it be that these atmospheric currents are not simply weather, but an unseen circulatory system of the planet, binding together regions and biomes that imagine themselves separate? Even iron drifts on these rivers. From deserts and dried lake beds, small particles take flight, richer than they seem, falling into oceans where they act as nourishment for blooms of plankton. A handful of dust in midair becomes a trigger for life in the sea. The sky leans down and feeds the water, invisible hands offering sustenance. And with that plankton comes more oxygen, more carbon captured, more balance restored or undone. The cycle is endless, a conversation between the ground, the air, and the ocean, carried not in words but in currents of dust we cannot see. These rivers don't just carry life, they carry memory of catastrophe. After great eruptions, sulfur particles scatter, cooling climates far from where the lava flowed. After deserts expand, their winds carry more dust, marking shifts in water, soil, and ecosystems. Even in ice cores far from deserts, we find those particles stacked patiently in layers, whispering of storms beyond the horizon. Each grain is a tiny archivist, carried distances no one could track in the moment, but marked forever in the record of stone and ice. There is a gentle paradox in these currents. They feel absent, located nowhere, and yet they touch everything. Not because we see them, but because we see their aftermath. Forests fed, soils darkened, skies red with sunset colored by particles. Maybe these invisible rivers are reminders that what we perceive as isolated, desert far from jungle, volcano distant from field, death in one place, bloom in another, are never truly apart. Maybe it is only air that knows this intimately, because it carries the threads and weaves them back into one cloth. At times these flows seem almost alive, bending around mountains, funneling through valleys, rising into the jet stream where they loop the globe in days. They act as memory in motion, shifting biology and geology alike without boundaries or pause. A breath that begins over sand may end above jungle, An ash plume born of fire may end as nutrients. A haze from one continent may become another's twilight. Nothing remains detached when the rivers connect them. Air itself erases separation. And still we are only beginning to understand the depth of their role. Could it be that the dust we sweep from a window carries atoms from another epoch? Could it be that when children breathe in rainforest air, they inhale seeds that began as dust across an ocean? We rest beneath these rivers without ever hearing them. Yet they shape the maps of life more forcefully than any boundary we have drawn. Perhaps in their silence lies their true wonder. They ask nothing of us. They are not seen by eye or owned by nation. They simply flow, a planetary heartbeat unnoticed, an erasure of distance that happens whether we remember it or not. We belong to them even as we fail to sense them. And so the question remains like breath itself. If invisible rivers can move deserts to feed forests, scatter dust to feed seas, and carry the echoes of catastrophe into corners untouched by its origin, then what else might be flowing above us right now? What memories tangled in dust, what fragments of endings and beginnings still waiting to drift into our lungs, our soils, our seas? And if invisible rivers of air can carry deserts across oceans, bringing dust and seeds into lives far beyond their origin, then we must remember that skies are never still. They shift not only with winds but with time, changing tone, hue, and chemistry in ways that civilizations once knew intimately, though we can only imagine them now. The skies of the earliest people, the ones who first looked upward and gave names to stars, were not the skies we look upon today. They were thicker, stranger, alive with veils of smoke, dotted with celestial patterns we will never see again, painted by a chemistry that has since faded. Perhaps the greatest loss is not what disappeared on land, but what no longer hangs above us. To breathe then was to breathe a sky tinged by wood smoke. Ancient hearths and endless fields of burning left subtle films of haze across valleys, altering sunsets into deeper reds, changing the stars into softer blurs. For millennia, people lived beneath skies tinted by the constant exhale of fire, fire that was both survival and signal, both warmth and warning. Even now soot can be found in ice layers thousands of years old, thin signatures of forgotten nights when the smoke of villages drifted into upper air, mingling with volcanic dust, lingering far longer than memory itself. Volcanoes, too, played their role. When great eruptions rose into the atmosphere, civilizations felt them without knowing their causes. Dust veils spread in silence, cooling climates, dimming harvests. To those who watched, the sky might suddenly grow pale, the sun dim, the moon turn red. These were skies of omens, skies that spoke in disappearance, teaching communities to fold their stories into the heavens. We find these echoes now not in chronicles alone but written in ice, in tree rings, in isotopes that record SO2 drifting invisibly where no one could see. Could it be that every story of a darkened sun, every whispered record of famine, every forgotten myth of fire in the heavens, is an echo of chemistry above, memory layered into the sky long before science gave it reason? There were stars, two patterns gone now, lines disrupted by the slow drift of Earth's axis, by precession, by cycles unfolding over tens of thousands of years. Constellations that once wheeled above early temples no longer ride the same sky. Light pollution and shifting air veil even what remains. And so, the forgotten skies are not only those of air and dust, but of the heavens themselves, constellations erased by time, their stories scattered across fragments of stone and silence. Maybe it is not only that we have forgotten them, but that the sky itself has moved beyond us. And yet, despite these lost visions, the air still carries faint traces of those older skies. Each breath contains molecules that watched those civilizations rise and fall. Some carry isotopic signals of ancient droughts that bent empires until they broke. Others carry particle residues from great fires long extinguished. If we could read the atmosphere precisely, with perfect sensitivity, would we not find every forgotten era preserved in its diffusing archive, not gone at all, but thinned into invisibility? Perhaps this is what makes us feel nostalgic even for times we never saw. Standing on a clear night, looking at a blue morning, there is a flicker of longing, as if some part of us remembers skies different from these, skies once filled with smoke and haze, skies layered with light not our own. We may not see them, but we breathe within their echoes still. And so the question presses forward gently. If skies can shift so fully that whole civilizations lived under veils we will never know, then how much of our own sky will one day be forgotten? What colors, what haze, what subtle changes will others breathe, centuries from now, and wonder? What skies did we once live beneath? What traces do we leave drifting silently above? And if the skies of ancient civilizations have already slipped beyond reach, leaving only echoes in myth and layers of ash within ice, then we might wonder how the sky itself records its memory. Clouds fade, winds vanish, sunsets cannot be preserved. And yet, despite its restlessness, air does leave fossils, fragile captures of breath, trapped by chance, sealed in amber and stone, clinging quietly to the underworld of time. These atmospheric fossils are rare, but they are proof that even the most elusive of things, the invisible weave of gases, can sometimes be held still long enough to be remembered. Imagine a drop of resin slipping down a tree trunk millions of years ago, catching a small insect, hardening into amber. Alongside its wing patterns and delicate antennae, there are bubbles, perfectly round, perfectly sealed, containing a fragment of ancient atmosphere, a pocket of air that dinosaurs would have breathed, locked in golden light. Scientists now pierce those bubbles gently and measure their content, reading oxygen levels, carbon dioxide ratios, finding whispers of climates extinct for millions of years. Amber, hardened sunlight made solid, becomes more than decoration. It becomes archive, holding the chemistry of vanished skies in its translucent glow. In caves too, air lingers. Stalactites and stalagmites grow one drip at a time, thin films of water layering minerals slowly, enclosing bubbles as tiny as dust motes. Within them, air is trapped, older than memory. Their isotopes tell us about rainfall, about drought, about carbon cycles shifting silently above. A stalactite is not simply stone but a barcode of atmosphere, each thin band preserving whispers of what forests once stood above and what gases drifted through their leaves. To walk through a cave and touch stone is to graze fingertip against frozen breath, the fossil of air itself. Even sediments at the bottom of lakes and oceans hold these traces. Tiny shells of plankton, foraminifera no larger than grains of sand, are infused with carbon isotopes from the water around them, which in turn reflects the atmosphere above. When they sink and layer, pressed into future rock, they lock these ratios in place like faint signatures. By reading them, we learn of warm ages when jungles reached nearer the poles, of ice ages when seas fell and deserts stretched wider, each shift marked as chemistry transformed into geology. It is delicate and invisible, and yet so persistent, air written into shell, breath nested in stone. And still, what humbles us most is how these atmospheric fossils survive against all odds. Air wants to leak, to diffuse, to vanish back into circulation. And yet, under specific conditions, it remains. Those ancient pockets remind us that memory need not be loud. Sometimes it is preserved not in grandeur but in the infinitesimal, the smallest bubble, the faintest shift in isotope ratio, the subtle hue of trapped minerals. Perhaps this is why they feel so haunting, because they are fragile survivors, breathless fossils of atmosphere's eternal motion. We might ask, then, how much is missing? How many skies passed with no record at all? Could it be that whole climates have disappeared without trace? Their air once as real as ours, now scattered into silence? Perhaps these fossils are less a complete history than they are fragments of a lost library. Clues too sparse to ever tell the whole story, reminders not of what we know, but of how much we can never recover. Still, there is comfort in their existence. Every fossilized bubble of air tells us that even breath, even invisibility, has a material footprint. Atmosphere is not untouchable, can be stored, held in crystal, caught in resin, absorbed into shells. Life and stone are always in conversation, even at the smallest scale, preserving memory without intention, saving echoes without purpose. And so we arrive here, at the notion that the atmosphere is not entirely fleeting. The air we inhale, though endlessly moving, sometimes agrees to pause, to rest inside matter, to wait for those millions of years until new beings are capable of noticing. Not because the world planned it, but because entropy allows fragments to linger in unlikely places. Tiny coincidences, sealed vaults of memory, reminders that even air has fossils. And yet, if such delicate traces can persist against time, hidden in golden amber or dark caves, then what other secrets might still be entombed, waiting in shells, in stone, in pockets beneath the sea, little fragments of atmosphere that know a world much older, much stranger than the one we breathe today. And if even the most fragile bubbles of amber can hold air from vanished worlds, then we must step back and remember that most of the atmosphere will never rest so still. For the air, like all things, is bound to entropy, the universal drift toward disorder, the quiet scattering of energy that governs both stone and storm. Entropy does not sleep. It rules the chemistry of stars as much as it rules the breath in our lungs. And though the atmosphere feels boundless and alive, it too is caught in this law, leaning always toward chaos, toward the quiet dissolution of order into something diffuse, spread, and even. Not because the sky is broken, but because time insists upon it. Heat rises, but not evenly. Every sunlit surface warms at a different pace. Every ocean reflects light differently. Every current carries heat unevenly across the globe. Warmth pools in some places while cold gathers in others, and the imbalance moves upward, weaving itself into wind. The result is motion, air rising, air sinking, air sliding, always redistributing. When we see storms, cyclones, cloudbursts, we are watching entropy at work, the attempt to disperse heat across the planet, brief spirals of imbalance that quickly collapse back into stillness. A storm looks alive, but it is also a fluctuation, a temporary swirl in the endless pursuit of balance. Perhaps that is what makes them beautiful because, like us, they are temporary resistances to entropy, gestures of shape against the slide toward evenness. Entropy also marks the fate of decay. Each rotting leaf, each fallen tree dissolving into soil, each body decomposed into minerals and gas, releases its energy in increments, scattering what was once contained. Even the air receives its share, carbon rising back into the atmosphere, methane bubbling from wetlands, oxygen gradually consumed. Nothing is locked forever. Everything disperses. You might say that decay is the entropy of life, and storms the entropy of air, two echoes of the same universal law. Could it be that existence itself is a brief slowing of entropy, a suspension where patterns hold, until, inevitably, they unravel? And yet entropy is not violence. It does not rush. It is soft, patient, inevitable. The storms will cease, the winds will flatten, the concentrations of gases will spread wider until differences fade again. We live in the span between, in the age where gradients exist, where imbalance sustains motion, where the atmosphere still dances because it has not yet equalized. The beauty of entropy is that it is both direction and mystery. It tells us what must happen eventually, but not when. And in the distance between now and then, history unfolds. Even geology reminds us of this truth. Subduction carries atmosphere into the mantle bit by bit, carbonates sinking into stone, returning eventually as volcanic exhalations. The cycle has no central order, only the scattering and the reassembly, the decay and the renewal. If air had memory, perhaps it would remember itself in pieces, always dissolving, always reformed. And so, is entropy not just the law of physics, but also the quiet forgetting embedded into time? Even memory scatters. Even breath dissolves into wider air. Entropy also touches perception. We see a storm now and feel its coherence, but the gases that make it swirl are already dispersing. We remember civilizations, but the record grows incomplete, lines blurred, signals lost to weathering and chance. Our own thoughts scatter in time. The details fade, the edges soften, meanings dissolve. The atmosphere itself is a mirror of our minds, always in motion, but always leaning toward dispersal, toward silence. Maybe this is why entropy feels haunting, for it mirrors not only the universe, but us. And yet there is wonder in the recognition. For without entropy, there would be no change, no patterns, no storms, no cycles of life and decay. The evenness entropy seeks is not yet achieved, and so we live in the interim. A fragile, golden pause where gradients still exist, where winds still create rivers of air, where heat still stirs oceans into motion. The inevitability of scattering makes each fluctuation precious, each storm and each breath miraculous. Not because they last, but because they don't. So we drift, beneath skies both ordered and not, part of the endless scattering that rules stars, oceans, and lungs alike. And perhaps the most haunting thought is not that entropy disperses everything, but that it leaves faint traces even while it does. Faint records sealed in stone, faint isotopes preserved in ice, faint scars left from storms now forgotten. Everything scatters, but not everything vanishes. And if entropy shapes the atmosphere, scattering it into histories both fleeting and preserved, then what does that say about dust? Particles so small yet so enduring, that drift endlessly across the world, carrying memory in their weightless silence? And if entropy scatters all things, dissolving storms and erasing records into silence, then dust may be its smallest but most eloquent instrument. It drifts quietly, overlooked, yet it has written whole chapters of Earth's story, not in stone or ice, but in fine, weightless grains carried across skies. Dust is the handwriting of deserts, a script that crosses oceans, linking faraway places into a single breath. To watch it through time is to realize how power is held not only in mountains and rivers, but in particles so small we can hold dozens upon a fingertip, particles that nevertheless shape forests, oceans, and even the fate of civilizations. Each year, winds rise above the Sahara, lifting billions of tons of dust into invisible currents. These grains, born of ancient stone ground by time and heat, are lifted into the air and travel thousands of kilometers, a caravan without borders. Some fall into the Atlantic, some reach the Caribbean, some settle deep within the Amazon basin. And there, this dust delivers iron, nutrients without which the rainforest could not flourish as it does. The luscious greenery on the planet partly owes its vitality to the barrenness of deserts, linked by air into a cycle as improbable as it is undeniable. Could it be that every leaf in the Amazon, every breath of oxygen released from its canopy, is written in part by dust grains carried from a desert half a world away? Dust travels north as well, toward ice, sprinkling Greenland and the Arctic, altering albedo, darkening snow until it melts just a little faster beneath the sun. It travels south into oceans, seeding plankton blooms that rise like unseen forests upon the water. Where iron settles in the sea, life pulses more strongly, and where it does not, sterile blue expanses remain barren. Dust is not merely the residue of deserts. It is the wandering messenger that ties land to water, life to stone. And it is not only nutrients that ride these atmospheric caravans, but memories of catastrophe. Layers of lust tell us of glacial grinding, when sheets of ice once pulverized stone into powder and winds scattered it across continents. Ancient layers of volcanic ash too become dust on the move, recording eruptions in subtle shifts of chemistry. Some carry traces of drought, others the signatures of fire, microscopic fossils of upheaval. To read Earth's dust is to read climate itself, scribbled across lakes, soils, sediments, delicate handwriting preserved despite the scattering hand of entropy. Dust has entwined itself with human history as well. It darkened skies during great droughts, teaching early empires what fragility truly meant. It carried pathogens on winds that spread unknowingly between villages and ports. It has shifted monsoons, raising floods in some places, silencing rains in others, deciding harvests with no counsel, no warning. Perhaps we forget too easily that the boundary between civilization and desert is narrow, and dust is always the quiet advance guard of that edge. It reminds us that stability is provisional, landscapes are porous, and no soil or sky exists in isolation. And yet dust is patient. It erodes mountains so slowly that we barely notice, but its grains accumulate into fertile plains, into vast river deltas where lives take root. Dust built our soils as much as any flood or forest, lending fertility to regions that would otherwise have remained barren. Perhaps this is why it feels almost like a paradox, that the smallest particles, drifting fragile and slow, have done more to link continents and sustain ecosystems than the heaviest rock or tallest mountain. Dust erases, yes, but in doing so, it also builds. Maybe this is what makes dust so haunting. It is both record and eraser, both messenger and mask. It blurs skies, softens light, carries nutrients, carries loss. It is entropy made visible, dispersed beyond recognition, yet still carrying meaning in its journey. Each speck carries the silence of what crumbled before it. Stone turned into atomized memory of mountain, of river, of life. Breathing in dust is to inhale the ghost of a world that once stood but has since been ground away. So next time wind rises and pale haze drifts across horizons, it may be that we are not only seeing a desert's breath but memory itself catching the air, crossing boundaries invisibly. And if these atmospheric caravans of dust can alter forests, oceans, and entire climates, then it is worth asking softly, what other invisible messengers are traveling above us, carrying pieces of forgotten worlds across the sky, reshaping what we think of as separate into something more deeply, invisibly connected. And if dust once linked deserts to forests, crossing oceans in silence and feeding the world far beyond its origin, then what are we now casting into the air? For unlike the grains of ancient stone or volcanic ash that carried messages of geology, the sky today holds strange new signatures, records born not of mountain or fire, but of us. We are a species that has learned to alter the very chemistry of the atmosphere not only by living, but by making. The traces we leave are no longer just breath or ash or dust. They are technofossils in the sky. Every city exhales, not only warmth and water vapor, but smog, fine aerosols, industrial dust. The haze that lingers above modern skylines has no analog in natural history. These are compounds forged in combustion, heavy metals from industry, nitrogen oxides, hydrocarbons, a new smoke with no ancient precedent. Smog becomes not only a veil shading the horizon, but a signature, an archive in the making. Centuries from now, the ice may hold thin bands that carry our exhaust as its own stratigraphic memory, a layer that whispers of an Anthropocene atmosphere unlike any before it. Could it be that what we now think of as pollution will one day be studied like amber or stalactite, a record of human breath pressed into chemistry? Other signatures are sharper, more haunting. In 1945, for the first time, radionuclides entered the sky not from a star or a supernova, but from a human hand. Atomic tests in deserts and atolls scattered isotopes of plutonium, cesium, strontium into winds that circled the globe. These isotopes have half-lives longer than our lifespans, longer than our societies, longer even than empires. The fallout became stitched into tree rings, ice cores, soil layers, a global timestamp that no species before ever left. Even if our cities erode and our languages fall silent, this signal in the sky will remain, an unmistakable geochemical relic. Not because we intended a mark, but because entropy ensured that every explosion scattered pieces of us into eternity. Plastics, too, now rise invisibly, broken into microscopic fragments carried by the same winds that once bore desert dust. They drift across continents, settle on glaciers, sift down into lake beds. Every year, particles of polyethylene and polyester and microfibers from our clothes and machines are caught by clouds and scattered like seeds we will never fully collect. They are nearly eternal, resistant to decay, slipping into the upper layers of soil and sediment, embedding themselves where future geologists might one day find them and say, "Here is where humans exhaled their presence into the world. Not bones alone, but polymers. Not only tools, but haze." Could it be that the true fossil of our time is not built of stone or shell, but of plastic dust falling silently from the sky? And in this we see the paradox: we are shaping a future record, but one that might endure beyond us. Our exhaust, our fallout, our plastics become a permanent strata. The air is writing our biography without asking us first. Each plume is both memory and warning. Memory because it will outlast our words, inscribed in chemical isotopes more durable than archives. Warning because we ourselves breathe it back, cycling our own signature through lung and leaf and ocean. Like all previous forms of atmosphere, it does not remain separate. It folds back into the fabric of life. Maybe, then, our presence is not only in the cities we build or the technologies we leave, but in the chemical chorus we have unleashed. The atmosphere today holds whispers of volcanoes, echoes of deserts, yes, but layered atop them, the hum of human activity, unmistakable. Our breath altered by industry, our sky marked by radionuclides, our air seeded with polymers that will not dissolve. Once, Earth's air carried only the exhalations of bacteria, of forests, of stone through eruption. Now it carries ours. And if air is memory, then our memory is unlike any before. It is tempting to imagine some future intelligence, thousands or millions of years from now, drilling into ice as we do, cracking open bubbles trapped in layers. They would release not only oxygen, but fragments of our age, the spike in carbon dioxide, the sudden markers of methane, the unmistakable isotopes of nuclear fire. Perhaps they would hold them a moment longer and wonder, who were these beings who left technofossils in the sky? Why did they burn so brightly, so briefly, and inscribe themselves so deeply? We stand here breathing the archive as we create it. Every inhale mingles with ancient isotopes and modern ones, with pollen and soot and microplastic dust. We have become architects of the sky's fossil record, not by intention, but by existence. And yet, while this thought humbles us, it also unsettles. If we are already leaving atmospheres behind, then what other signals might still accumulate in silence, waiting for someone or something to read them long after we are gone? And if our own technofossils drift now in the sky, whispering of industry and invention, then we are only the latest in a long sequence of atmospheric signatures left behind by forces greater and stranger than ourselves. For there have been other times when the sky was rewritten, not by living hands, but by sudden encounters from beyond. When fire and metal from deep space struck the Earth, the atmosphere was transformed in an instant, turned briefly into both executioner and creator. A meteor impact is unlike volcano or storm. It arrives without warning, faster than thought, older than the worlds it collides with. A fragment of stone or iron, drifting for millions of years in silence, finally meets our planet with energy beyond comprehension. In those moments, air ceases to behave as air. The shockwave compresses it into fire, the molecules themselves igniting against the incoming body. A sky lit not with light alone but with plasma. And when the intruder strikes, the land itself explodes upward, ejecting molten rock and dust so high that air becomes ocean, filled with fragments drifting around the globe. The atmosphere, in seconds, turns into archive. We know this most clearly from the end of the Cretaceous, some 66 million years ago. The asteroid that struck near what is now Chicxulub transformed the skies of the entire planet. Dust and sulfur cascaded upwards into the stratosphere, dimming the sun for months, perhaps years. Photosynthesis faltered. Ecosystems starved. Dinosaurs, rulers for over 150 million years, took their last breaths beneath skies clogged by their executioner's haze. Yet at the same time, new beings survived those skies, small mammals and resilient plants that adapted to the dim cold. When the atmosphere cleared, it was not the same Earth at all. The executioner left behind a new script for life to follow. Could it be that every extinction is also a kind of cosmic editing, the air itself choosing, through catastrophe, what story will be carried forward? But not all meteors were endings. Some carried beginnings. In their cores rested metals rare or absent on Earth's crust, iridium, platinum, even amino acids locked into stone. When scattered through the atmosphere, these elements settled into soils, lakes, and oceans, becoming part of the chemistry of our planet. Each impact was therefore not only a catastrophe, but also an offering, a seeding of something unfamiliar. Perhaps even the spark of life as we know it began in this way, not from silence alone, but from the noise of fire and iron falling from the void. Geology records these events not in stories, but in layers. Thin seams of clay shot through with iridium mark horizons where the world changed suddenly. Glassy spherules, formed when rock vaporized and rained back as droplets, are embedded in ancient strata. Shocks within quartz crystals tell of energies so immense they fractured atomic structures themselves. These are fossils not of animals, but of atmosphere, moments when skies turned violent, baked into stone. And yet, one cannot help but imagine what it felt like to breathe beneath such a sky, What did it sound like when the shockwave moved across continents? A roar beyond thunder. How dim did the days become when dust occluded the sun, when the world darkened into twilight? Did the creatures that survived sense that they were breathing the residue of fire, the metallic exhale of stone born elsewhere in the universe? Maybe, maybe not, but the atmosphere remembered, and it carries those memories in particles still measurable, even now, by the tracers of isotopes scattered in its wake. Perhaps the most haunting thought of all is how brief these events are in their cause, and how everlasting in their consequence. A fragment no larger than a mountain passes through the atmosphere in seconds, yet its dust lingers in the air for centuries, its scars lasting for millions of years. Whole ages are redirected by a body that itself disappears. Maybe this is the essence of a sky of fire and metal. Its creativity lies not in its permanence, but in its sudden rewriting of what endures. And so, once again, the atmosphere becomes both page and pen. It holds the poisons, the dust, the new elements scattered across its breadth. It delivers endings in the darkness that follows, but it also delivers beginnings in the metals it gifts to soil and sea. The air changes, the chemistry shifts, but the memory remains. And if the sky has already rewritten life in moments of fire and stone, then we must wonder, softly, with humility, what else lies waiting in silence beyond us, adrift in the dark, waiting for its chance to write its message across our air? And if skies of fire and metal once dimmed the world into darkness, then there were also times when the air moved in the opposite direction, when instead of cold and silence, the atmosphere wrapped the planet in heat. The greenhouse world, stranger and more vivid than our modern climate, has come and gone more than once in Earth's deep history, as if warmth itself were a dream that the planet drifts into and out of. These were times when jungles grew where today glaciers sit, and crocodiles basked near latitudes we now think of as frozen wilderness. It is worth asking softly, could warmth itself carry memory, etched into every layer of stone and air, reminding us that the atmosphere has dreamed hot before? In the Paleocene-Eocene thermal maximum, 56 million years ago, carbon spilled into the air in volumes vast enough to shake the stability of oceans and forests alike. Nobody knows the full cause, perhaps volcanism, perhaps sudden releases of methane hydrates from the seafloor, but the result was the same. A planet fevered, wrapped in a blanket of greenhouse gases that turned cold latitudes into tropical havens. Palm trees stretched into Arctic regions. Reptiles flourished where ice would one day reign. Oxygen isotopes in shells we now uncover tell us the warmth was global, ocean and air rising together in a harmony of heat. For over 100,000 years, Earth remained in that dream, a world unrecognizable but entirely real. And this was not the only time. Throughout the Mesozoic, the age of dinosaurs, skies often held more carbon dioxide than today, and the climates they wove made Antarctica green, forests thriving under pale seasonal light. Fossils beneath ice show root systems that once bound soil there, leaves that drank sunlight in months of near night. Creatures we think of as cold-blooded became broad rulers, partly because the air was warmer, richer, and more stable across latitudes. Warmth reshaped who could live where, cropping deserts with rain, pushing jungles outward, making the earth smaller in distance but larger in richness. Could it be that warmth itself is less destructive than it is redistributive, rearranging life, expanding the margins of where things are possible, just as cold once tightened them? But greenhouse worlds hold dangers too. Warmth quickens cycles. Weather grows stronger. Rain falls heavier, rivers flood. Oceans absorb carbon until acidity mounts and shells dissolve. Entropy, even in heat, keeps scattering balance, pressing systems until they collapse. In thermal maxima across deep time, extinctions were not sudden but drawn out, a quiet suffocation for species unable to shift quickly enough into the new configurations of warmth. Warmth remembered them only as fossil traces and isotope fingerprints. Maybe warmth is not gentle, but persistent, an archive written not in sudden fire, but continuous years in which conditions never relented. Even now, we live in a greenhouse period, though gentler, though unfamiliar. We think of it as an intrusion, a change, but to the earth it is an echo, a rhythm it has carried before. The difference is our presence, our voices, our vulnerability to small shifts. Crocodiles can colonize warmth in ways we cannot. Humans are bound to coasts, to harvests, to fragile patterns in monsoon and frost. The warmth we enter now feels threatening because our memory is short, and we have remembered primarily the colder phases of Earth. Cycles where ice carved history and stability looked like balance. Yet beyond ice, the Earth has dreamed long, humid dreams. Perhaps we are only stepping into one it has dreamed before. Still, one cannot help but feel awe at the thought of jungles where tundra stands today, broad forests erupting across poles, coral reefs thriving in seas now snowed. When we hear the call of greenhouse epochs, we are reminded of possibility, not constraint. Warmth can erase borders as surely as dust connects continents. Warmth expands niches, creates new relationships, remakes the very geometry of ecosystems. Perhaps what we fear is not only loss but unfamiliarity, the prospect of breathing air attuned to a different era, one with no memory of us in it yet. For if warmth can spread deeply enough to fold itself into stone, to bend fossils into forests where they should not exist, then warmth, too, holds a kind of memory. A slow, wet memory in which alliances between air and life shift, in which Earth rehearses climates that seem unthinkable to us, yet are as natural to her as glaciers and deserts. And if warmth has occurred before, then maybe it is less an intruder than a recurring dream, one that arrives when carbon rises and stays until balance can be found again. Not because the world desires it, but because its cycles demand it. And so we are left in this gentle and haunting thought. If Earth remembers both ice and fire, both cold silences and warm expansions, then perhaps we, too, now breathe inside a dream larger than our comprehension. And if the dream of warmth has had such power before, lifting jungles to poles, filling oceans with strange flourishes of life, then what might tomorrow's atmosphere remember, not of fire or meteor or ice, but of our own voices reshaping its warmth again? And if warmth itself can be remembered by Earth, if jungles at the poles and oceans of breath remind us that even climate can dream, then we might turn our gaze upward and outward to wonder if the atmosphere is only a story of Earth, or if it stretches farther, past the edges of the sky, into the openness of space itself. After all, the air does not end cleanly at some invisible boundary. Thins, yes, it fades, dissolving into silence. But even there, it does not vanish. It merges softly into the air between stars. Cosmic dust drifts endlessly across space, particles shed from collisions of asteroids, from tails of comets, from the death throes of ancient stars. Every day, hundreds of tons of this dust spiral down into Earth, passing quietly through atmosphere, burning slightly or simply settling into the planet's skin. Some of it vanishes into oceans, some into soil, some into our lungs. If our own air carries memory of forests and volcanoes, these cosmic particles add whispers from elsewhere, from the birth of stars, from galaxies beyond sight. Perhaps each breath we take always contains not just Earth's memory, but the faintest trace of the wider universe. The borders blur further in the tenuous upper reaches, where Earth's exosphere mingles with the solar wind. Hydrogen atoms escape into space, and interstellar atoms wander inward, kept for a moment in delicate balance by magnetism and gravity. The atmosphere at its boundary is not entirely ours, but not entirely the universe's either. It is a region of exchange, a threshold. Could it be that atmospheres are not isolated at all, but porous veils, brushing against each other across time, connecting planets faintly through drifting particles of gas? Even cosmic rays leave marks in our air, high-energy messengers from the depths of galaxies. They ionize molecules, spark small cascades invisible to us, their fingerprints etched into isotopes like carbon-14. Through them, the sky becomes both shield and collaborator, absorbing energy from space and quietly recording it in matter below. A fragment of a supernova explosion, reaching us millions of years late, might end its journey here, in the thin film of gases that makes Earth inhabitable. Maybe the very atoms shed from dying stars are still with us tonight, making air not local but cosmic. And then there is starlight. It passes through our atmosphere each night, bending, scattering, giving us sunsets of red and twilights of violet. But starlight carries more than beauty. It carries heat, information, memory of its origins fused within collapsing cores. When we see a star, its light is already old, sometimes older than human history, sometimes older than our species itself. And yet all of it must first pass through the thin veil of air around us, the filter that colors it before it touches our eyes. Through this veil, the universe modifies its message, translated subtly into human vision. The atmosphere is, in this way, not only Earth's memory, but also a translator, a lens through which the cosmos whispers. Perhaps then, we must admit that Earth's air is not entirely Earth's alone. Pieces of it are borrowed from comets, from asteroids, from stellar winds scattered into the solar system. Some of it leaks away slowly, drifting toward other orbits, into space, into the gravity wells of other worlds. Just as dust carried across the planet connects desert to rainforest, perhaps space too carries an even wider flow, air blending invisibly with the galaxy around us. Could it be that atmospheres themselves are temporary islands in a greater cosmic ocean, always exchanging, always shifting, their borders never fixed? When we breathe, we call it oxygen of this planet, nitrogen of this sky. But trace atoms may have origins more distant, fused in a star billions of years ago, wading through vast arcs of time, only to descend here, entering us now. Every molecule has a history older than Earth, older than ice or fire or dust. Breath itself reaches back into the galaxies that preceded us. And if so, then we carry a little more than atmosphere inside us. Perhaps within every inhale there is also a memory of stars. And so the question lingers, gentle, unresolved. If our atmosphere is entangled with cosmic dust, with starlight, with the air between stars, then are we breathing Earth alone, or are we always breathing the universe itself? And if every breath we take contains atoms that once drifted between stars, then perhaps we should look not only at what the atmosphere inherits from outside, but at the fleeting forms it sculpts within itself. Among the most ephemeral of these are clouds, bodies made of nothing more than vapor, yet bodies that shape the rhythm of heat, light, and life across the earth. They are temporary monuments, identities that last minutes or hours, yet regulate the future of continents and seas. To watch a cloud form and dissolve is to witness a pattern as ancient as oceans rising, but as transitory as a sigh. A cloud is born not from nothing but from memory. It begins when invisible vapor, lifted upward, clings to dust particles floating in the air, perhaps fragments carried from deserts, perhaps remnants of salt lifted from waves, perhaps ashes from distant fires. Around these seeds, droplets condense one by one, until billions of them cluster together, scattering light into white form. Each cloud is an assembly of particles fine as whispers, gathered around tiny nuclei of history. The dust that once fertilized a forest may now act as the heart of a cloud drifting over another continent. Maybe clouds are less sky and more archives, briefly visible appearances of invisible memory made luminous. Their shapes are fleeting, but their influence is vast. Clouds shade the world, reflecting sunlight into space and cooling the planet below. They warm at night, trapping infrared heat, wrapping the earth loosely in a veil. They carry rain across continents, feeding rivers, filling aquifers, sustaining crops as though delivering parcels of life folded into drops. Every storm is not only a disruption but a gift, water carried hundreds of kilometers from where it first evaporated. Could it be that clouds themselves are curators of balance, deciding by their presence or their absence whether an age drifts toward drought or toward nourishment? And yet, clouds confuse more than they clarify. To scientists, they remain one of the most uncertain players in climate, sometimes amplifying warmth, sometimes dampening it, depending on their form, their height, their cycles. Stratocumulus banks blanket oceans, cooling them. Cirrus filaments drift thinly and trap heat. Cumulonimbus towers rise violently, delivering torrents of water and energy before thinning again into blue. Each cloud is temporary, but collectively they decide outcomes greater than empires. Not because they will themselves to, but because entropy expresses itself through vapor as much as through stone. But there is also a quiet intimacy in clouds. They are the only part of the atmosphere that we can truly see with our eyes. Air is invisible, gas is intangible, But clouds are the atmosphere revealing itself, offering texture, giving shape to the otherwise unseen. Standing beneath them, we see form where there is only flux, identity where there is only circulation. It is as though the sky breathes in patterns we can briefly understand, hinting at its own complexity before dissolving into vagueness again. Perhaps this is why humans have always looked upward and found stories in clouds. Faces, animals, omens, projecting meaning onto bodies that hold none, but invite all. They are also thresholds. A cloud is not only above the land, it touches it through rain. Every droplet that falls carries chemistry of the clouds making traces of salt from an ocean, sulfur from a volcano, industrial soot from a city, pollen from a forest it passed over. Rain is not only water but an archive released. And when it falls to soil, when it enters rivers, when it supports roots, that archive is absorbed into the ongoing record of life. The cycle is unbroken. Evaporated water carrying memory upward, condensed into cloud, released again as rain to be absorbed, evaporated once more. Clouds are records in motion, looping endlessly. And yet, what is most haunting is how easily they slip away. A cloud can dissipate in moments, droplets evaporating back into invisibility. Its grand architecture, seen towering in the sky, can be gone within minutes. And so clouds remind us of impermanence, the fragility of identity, the fact that even vast appearances dissolve into silence. Maybe this is what makes them so resonant to watch. Each one is both monument and vanishing act, a body that never intended to last. So we are left with the question, if clouds can hold such power in their brief lives, regulating oceans, shaping summers, filling soils, and deciding harvests, then what does it mean that something so fragile, so passing, carries within it the fate of continents? And if their identity is fleeting, evaporating before our eyes, then what other parts of the atmosphere are less solid than we imagine, less permanent than we trust, quietly vanishing while shaping the very conditions that make us possible? And if clouds themselves can vanish while shaping the fate of oceans, then what of creatures whose breath once mingled constantly with the air, now gone in silence? For just as the atmosphere remembers fire, ice, and dust, it also remembers the living inhalations of those who no longer walk upon the earth. The mammoths, the giant sloths, the towering herbivores of ancient plains, when they breathed, they did not only sustain themselves, they added their rhythm to the greater cycle of gases. And when they disappeared, those rhythms ended too. Extinction is not just the vanishing of bodies. It is the vanishing of exchanges, entire conversations between life and air falling quiet forever. A mammoth's lungs were vast, drawing in volumes of oxygen across cold steppes, releasing carbon dioxide as it grazed through endless grasses. Herds of them would have exhaled together, their vapor rising like morning mists, joining cycles of the atmosphere in consistent, rhythmic tones. Giant sloths, moving slowly through ancient forests, took in air laden with moisture and pollen. Exhaling it changed, a subtle addition to the chemistry around them. Each species is not only a body but a partner in dialogue with the sky. Their removal tilted that dialogue, even if faintly. Could it be that silence in the atmosphere is greater than we thought? That it expands not only when forests burn, but when lungs stop forever? We know this too in subtler ways. Large grazers shaped vegetation, and that vegetation altered the flow of gases, the pull of carbon into soil or air. When mammoths vanished, steppe turned into tundra, broad cycles of carbon storage shifted. When giant sloths were gone, forests no longer dispersed seeds across distances they once did, changing the very distribution of plant life, altering how carbon was pulled from the atmosphere. Extinction breathes not only in absence, but in cascade, a ripple of missing breaths that reorganizes the chemistry of skies. Not because creatures intended it, but because life and air are one argument, one shared conversation. Scientists see these shifts faintly in sediments and isotopes, in changes in pollen trapped in layers of peat, in carbon storage altered after extinctions. Fossilized soils in Siberia hold signatures of vegetation that once thrived under mammoth herds. After they were gone, methane rose more freely from thawing ground. A difference in biology became a difference in atmosphere. Again and again, Evidence suggests that when breathing giants end, the air itself undergoes a subtle transformation, carrying their absence invisibly forward. And yet memory lingers. Within bones are isotopic traces of their diets, within fossilized dung, rare but telling, are the signals of gases exchanged, the patterns of ecosystems now altered beyond return. To study them is to hold faint remnants of conversation, lost notes of a long dialogue between beings and atmosphere. But unlike bubbles in ice or layers of ash, these records are fragile, scattered, easily erased by time. Breath is rarely fossilized, yet its absence speaks across the ages. We live surrounded by this quiet loss, though we rarely pause to feel it. The sky we breathe now is already missing lungfuls it once held. The constant respiration of species no longer here. Even birds silenced by extinction would have played their part in those gas exchanges. Every vanishing trims something from the atmosphere's complexity, its balance lessened by absence. Perhaps we imagine extinction as bodies lying still, but it is also this, molecules that will never again be exchanged in the exact way they once were. Extinction reshapes air, not visibly, not dramatically, but permanently. And maybe there is something deeply humbling in this realization, that our own breath is entangled with all who have ever lived, that each exhale joins the archives of the atmosphere, layered upon those of mammoths and sloths, but also layered upon absences where voices are lost. Could it be that the sky still carries something of them, diffused but present, an inheritance mixed so thoroughly we forget its depth? Or has their chemistry dispersed completely, carried into silence beyond recognition? When we breathe here, tonight, we join our rhythm to air that has been thinned by losses, enriched by births, shifted by countless extinctions. Breath is not personal. It is planetary. Perhaps what whispers to us in quiet moments is not simply oxygen, but a memory of all the lungs that came before, and all the silences that followed. And so we must ask gently, as the night drifts forward, if the sky remembers the lost breaths of mammoths and of giant sloths, then what does it mean that our own breath too will one day fade into that same archive? And might the air itself carry the silence of us, mingling invisibly with all that was forgotten before? And if the lost breaths of mammoths and sloths still linger faintly in the fabric of air, replaced now only by silence and dispersal, then it becomes clear that breath itself is confined by boundaries. For the atmosphere is not endless. It is not the world, and not the void, but something in between. A threshold, a fragile veil stretched thin across the planet's surface, at once protective and impermanent. All living memory resides inside this narrow shell, a few kilometers of gases held close by gravity. Step higher, only a little higher, and memory thins until there is no breath at all, until silence becomes complete. From below, the sky may feel unbounded, an infinity of blue or of stars, but physically it is astonishingly slight. Less than 1% of the Earth's radius holds all that is breathable. Mountains climbing to the heavens already graze its limits. The place where plains rise, where clouds form, where winds circle, is only a shallow skin compared with the depth of oceans or the thickness of stone. And yet that film contains everything we have ever known of air, every breath taken, every storm weathered, every whisper released. Could it be that life exists not on Earth as a whole, but within this borderland alone, caught between solid rock below and vacuum above? The threshold is both buffer and bridge. It shields us from ultraviolet rays, filtering the sun's fire into something tolerable, yet still passes enough warmth and light to sustain growth. It slows meteors, burning them into shooting stars instead of catastrophic impacts. It catches volcanic gases, diluting them across winds, dispersing them into scales large enough that balance can sometimes return. To pass from ground into atmosphere is to enter protection, but to pass from atmosphere into space is to feel its true fragility. Not because the air wishes to vanish, but because gravity can only hold so much, and entropy is always pulling it away. This veil is layered, stratified by temperature and pressure, each zone with its own secrecy. Troposphere with its clouds, stratosphere bearing the ozone that absorbs ultraviolet light, mesosphere where meteors flame out, thermosphere where faint auroras shimmer. To travel upward is to move into colder, thinner, quieter layers until finally, at the exosphere, gases begin their escape into space. Molecules drift apart, some never to return. Even here, even at Earth's edge, atmosphere is still part of memory, but stretched so thin it is almost silence. Perhaps this, then, is what it means to live at a threshold, to exist in a place where memory is dense enough to breathe, but light enough to vanish with a single step beyond. The Earth's oldest civilizations sensed this without science. Many spoke of the sky as a dome, a thin covering over the world. In their myths, heavens were fragile, delicate, liable to be broken open. And science has revealed this intuition was not far from truth. The atmosphere is a membrane, not invincible. A single thinning of ozone reminded us of its vulnerability. Carbon accumulation reminds us of its malleability. It is living not in permanence but in flux, constantly renewed, constantly altered, constantly risking the balance it provides. Perhaps that is why standing on a mountain or riding in an aircraft evokes unease. Because here the veil already feels thinner, its presence more conditional. Air pressure drops. Your breath grows more difficult. It becomes clear, even without instruments, how precarious this buffer is. Only within certain limits can we exist comfortably, and beyond them is silence. A silence that begins only a few kilometers above the ground. Could it be that what feels endless from below is really one of the most fragile structures of all? And yet, what a paradox. The atmosphere is fleeting, yet essential. It is small in extent, yet vast in effect. It is fragile, yet for 4 billion years it has protected, shifted, evolved, and carried every signature of change. It embodies the tension between permanence and impermanence. Perhaps that is what thresholds always do. They allow crossing, but not without awareness of what is left behind. They remind us that edges are not boundaries alone, but also places of transformation. So we linger here, aware that everything we know exists within a space not much thicker, proportionally, than the skin of an apple. This is the veil that separates memory from emptiness. This is the threshold where noise fades into silence. And if this much can be lost only a few kilometers higher, then what else, hidden or forgotten, may already have dissolved into the quiet beyond? And if the atmosphere is nothing more than a fragile threshold, a veil that both protects and exposes, then it is on this thin stage that we first began to alter it with our own hands. Long before machines or metals, before cities and smog, humans learned to call upon one of the oldest forces tied to air, fire. To burn is to transform the atmosphere directly, to take what is solid in wood or grass and release it upward into sky as smoke, soot, and heat. In learning to summon fire, we entangled ourselves with the chemistry of air in ways no species before us had done with such intention. Every flame has been both tool and signal, a flicker of light and an inscription in the wind. Fire is not invention but discovery, a reminder of what was always latent in the world. Oxygen, rich and restless, eager for electrons, waits constantly for release. Carbon inward holds its own kind of memory, gathered slowly from sunlight by leaves, year after year, locked into rings, fibers, and sugars. Bring a spark, and suddenly that held sunlight returns as heat and light, carbon released, oxygen bound, particles scattering upward. To sit by fire was to sit at the edge of an atmospheric transaction. The atmosphere inhaled by forests given back in a single burst, rising in smoke. Could it be that the first fires humans tended, half fearing and half dependent, were also the first time the atmosphere bore human signature in earnest? A techno-signature not in plastic or steel but in soot. Archaeology tells us fire traces stretch back hundreds of thousands of years. Charcoal fragments folded into ancient soils, black specks sealed in sediment, reveal the presence of deliberate burning. Wherever humans wandered, landscapes changed. Grasslands were kindled to flush out animals or to make space for new growth. Forest underbrush was tamed by controlled flames, managed into mosaic habitats that grew more diverse through burning than they would have without it. In Australia, in Africa, in the Americas, clouds of smoke rose from human intention long before cities were imagined. These flames were small, but the atmosphere noticed, absorbing their particles, carrying their scent farther than sight. It was the beginning of our entanglement with the veil of air, the practice of writing presence into sky. Fire altered more than landscapes, it altered time itself. Wood that would have decayed slowly over decades burned away in hours, collapsing futures into moments and joining air sooner than entropy would otherwise allow. Where decay rode its cycles slowly, fire hurried them, scattering carbon and energy in rushes of heat. Each fire condensed years of growth into fleeting light, all of it carried upward into the fragile, finite threshold above. Not because we fully understood, but because we desired warmth or smoked meat or cleared land, and through desire, the conversation between humans and atmosphere changed. The chemistry of soot is quiet yet telling. Tiny black carbon particles linger in ice cores, markers of ancient burning. Some date back to periods when climate shifted, suggesting humans and fire altered not only forests but atmospheric balance itself. It was subtle at first, folded into the natural background of lightning strikes and volcanic plumes. Yet intention mattered. A species had emerged that could transform atmosphere deliberately, bending fire to its will, and in turn bending air. Could it be that ours is a history not only of survival but of smoke, each flame a step deeper into partnership with atmosphere? Even today, fire reveals this entanglement. Forests burn naturally, yes, but now also from human spark and carelessness, sometimes in vast blazes visible from space. These fires stitch their signatures into sky. Carbon dioxide rising, aerosols scattering light into red dawns and dusky twilights, soot darkening ice far to the north, hastening melt. What began as campfire now scales across biomes, leaving imprints far larger than the spark that began them. And still, the chemistry is the same as it was when the first ember was coaxed into life. Breath, carbon, oxygen, a constant dialogue, only louder. Yet there is also a paradox of intimacy in fire. To sit at its edge is to feel in one's lungs the very combustion unfolding before the eyes, to breathe in smoke even as light warms the skin. Fire is atmosphere made visible, air entering flame, then drifting outward changed. We breathe it because we are part of the same circulation, bound without separation. There has always been this closeness. Fire is not separate from us. It is inside our lungs, inside our atmosphere, inside our history. So as we linger in this thought, watching embers fade and smoke rise into night, we might ask, what did the first fire write into the atmosphere that remains today? Could that early smoke still trace faint echoes in distant ice, layered as soot within glaciers, mingled with all the volcanoes, all the dust? And if every flame carries our presence into sky, what is the atmosphere now becoming? An archive of forests and deserts, yes, but also an archive of our own breath, our own burning, our own entangled story with fire? And if fire was the first way we learned to bend air toward our desires, then there are other fires waiting still, hidden not in forest or ember, but in ice and sea. There lies a more ancient fuel, silent and unseen, yet powerful enough to tilt the entire climate if released too quickly. Methane, trapped for ages in hydrates beneath frozen tundra and ocean floor, sealed in crystalline cages of water and gas. Not flames, but ghosts of fire, waiting in silence. They exist on the borders of stability, frozen under pressure, harmless as long as they remain locked away. But when warmth presses upon their prison, the cages begin to weaken, and the ghosts stir. Methane is a strange memory. It formed in ancient sediments, created by microbes or by the slow chemical breakdown of buried matter. Layer upon layer of it accumulated beneath the ocean's cold surface, frozen into hydrates like glassy lattices, crystalline vaults containing gas in vast amounts. 1 cubic meter of this ice-trapped methane can expand into 160 cubic meters of gas when freed. The scale is staggering, enough trapped beneath seabeds and permafrost that, if it all were suddenly released, the climate would shift not by centuries, but by decades, maybe by years. Perhaps these are the air's most patient ghosts, hidden in silence, waiting to remind us of just how fragile balance truly is. In deep time, methane releases have happened before. Layers in rock whisper of intervals where sudden spikes of carbon isotopes mark catastrophic warming. Scientists trace one such event to the Paleocene-Eocene thermal maximum, when the Earth warmed rapidly, oceans acidified, and ecosystems faltered under heat. Was it methane hydrates unraveling from thawing seas? A pulse so massive it overwhelmed every rhythm life had made? The fossil record does not answer fully, but the isotopic scars remain, evidence of ghostly exhalations that rewrote atmosphere and climate alike. Could it be that what lies dormant under today's ice is already rehearsing that memory, waiting for a signal to stir again? Even now, in Siberia and the Arctic, strange craters gape, where thawing permafrost has released sudden bursts of methane, explosions leaving scars on tundra. In oceans too, plumes of gas seep from the seabed, often small, often harmless. Yet each is a reminder that the stability of hydrates is no guarantee. Warming seas nudge them toward instability. Rising temperatures thin permafrost lids. What feels solid underfoot or under wave might in truth be little more than a lid pressed over restless gas. A still silence above a waiting storm. To breathe methane, to imagine its release, is to remember that it is far more potent at trapping heat than carbon dioxide. Molecular for molecular, it holds heat with greater persistence, a ghost far weightier than its size suggests. And though it fades from atmosphere faster than carbon dioxide, its presence can set dominoes falling, warming oceans, thawing more permafrost, unlocking further hydrates. A feedback loop, a chain of ghosts exhaling one after another, each release coaxing the next. Not because the Earth intends collapse, but because chemistry is indifferent, and entropy has no allegiance. And yet methane, too, is memory. Inside each hydrate is a story of ancient microbes, ancient decay. Released, it tells of times when ice was thicker, seas colder, pressure greater. Each bubble rising from seafloor carries a fragment of that story into the present, as if the very ground were sighing with restless history. To stand on tundra, to see a methane spring bubbling from thawing soil, is to watch centuries melt into atmosphere before one's eyes. Perhaps what unsettles us is not only the warming it brings, but the reminder that the past remains unfinished, always able to return. Still, the ghosts remain mostly hidden, vast reserves only revealed through seismic maps, through measurements of submarine ice layers deep under pressure. We cannot see them with our eyes, yet we live above them, walk above them, breathe above them. They are part of the invisible inheritance of our world, as real as mountains but far more fragile. What if the greatest changes to our atmosphere are not decided by volcanoes, or fire, or dust, but by the quiet unsealing of ancient vaults we cannot even reach? So we wait, watch, listen, knowing that beneath the ice and sea drift these silent stores of breath, unseen but not forgotten, invisible but not harmless. Perhaps they are not only ghosts but clocks, timers of a kind, marking how long stability may last. And if they stir again, what kind of air will we find ourselves breathing? Will warmth become its own cascade, too swift to follow, too vast to remember? And if methane ghosts wait in silence beneath ice and sea, whispering of futures that could unfold with sudden warmth, then we must ask, how do we even know their stories? How do we listen to the breath of epochs long vanished? The answer lies not in what we see, but in what atoms silently remember. For within the structure of molecules themselves, in the absence or abundance of subtle isotopes, the atmosphere has kept a diary, written invisibly, yet legible to those who learn its script. Nitrogen, oxygen, carbon, their isotopes are memory made physical, ratios that testify to ice ages and floods, droughts and blooms. An isotope is simply an atom with a different weight. Oxygen with one or two more neutrons, nitrogen slightly heavier or lighter. To the eye, they are identical. Yet, in the way they circulate, they behave just differently enough that the atmosphere writes its shifts upon them. In colder times, lighter isotopes of oxygen are pulled into snow more easily, falling onto ice sheets and locking the signal away for tens of thousands of years. In warm ages, the heavier isotopes remain more common in oceans, marking those epochs in shells and corals. To trace them is to trace climate itself, subtle ratios becoming guides through landscapes of time we cannot otherwise enter. In Greenland's ice cores, layer upon layer reveals this record of isotopes. Each winter snowfall, each season converted into crystal, traps oxygen signatures that speak of atmospheric temperatures stretching back 800,000 years. The flickers of glacial advance and retreat are seen not in fossils, not in stone, but in mathematical readings of isotopic differences. Every age leaves a fingerprint, every thaw a small adjustment in the ratios of atoms. Perhaps there is comfort in this, that even when landscapes and species vanish, the atmosphere has saved their memory in code too fine for chance to erase. Nitrogen, too, becomes a witness. Its isotopes in nitrate layers, in sediments, in ice, reveal cycles of fertility and drought, telling of ancient monsoons rising and falling, of river systems collapsing into dust, of oceans shifting oxygen levels deep within their waters. The heavier isotopes accumulate when denitrification takes hold, when oxygen dwindles in seas and microbes alter chemistry as they starve. In these quiet signals, we read the story of oceans suffocating, of great extinctions foreshadowed by chemistry long before they arrived. Could it be that isotopic memory is more truthful than fossils themselves? Less dramatic, but more continuous, always recording, never sleeping? And yet, isotopes are quiet to the point of invisibility. They are not seen with the naked eye, not felt on our skin, not heard in breath. They are the pages of time written in ink so subtle we almost fail to believe they exist. Specialists sift through ice, through stalagmites, through ancient shells of microfossils, measuring ratios of carbon-13 to carbon-12, oxygen-18 to oxygen-16, nitrogen-15 to nitrogen-14. Behind each decimal lies climate, season, epoch. Not because atoms know history, but because physics and chemistry cannot help but leave trace. Memory is not intentional. It is consequence. Perhaps this is the deepest lesson of isotopic memory, that history hides not only in the dramatic, but in the ordinary, layered where no eye expected to look. The fall of empires may leave stones, the breath of mammoths may fade, but chemistry keeps watch without asking. Light and heavy atoms carry on their uneven paths, diverging, converging, testifying silently. Memory, then, is less about willpower than about difference, minute, near weightless difference that nonetheless decides what is preserved. And what of us? Every breath we exhale shifts carbon isotopes in the atmosphere, fueling what scientists call the Seuss effect, the dilution of carbon-14 by our burning of ancient fossil carbon devoid of radioisotopes. Already, that imprint is visible in corals, in ice, in trees. We are etched into the ratios, our century only a thin line in deep time, but bright enough to be legible long after we are gone. Our story is carried not by monuments or language alone, but by isotopes in shells, snow, and air, a code that will outlast us even if memory in all other forms erodes. So as we breathe tonight, we share air rich in isotopic testimony, ratios that once marked ice ages shifting, oceans burning with warmth, species rising and disappearing. We quietly inherit this diary, though we rarely realize it, and the thought lingers, suspended like dust in twilight. If atoms keep time with such subtle fidelity, then what other stories are written in silence all around us? Records of floods, of forgotten warmth, of vanished skies, waiting only for us to learn how to read them? And if isotopes are diaries, inscribing the rise and fall of warmth and ice in quiet ratios, then sometimes the air writes history in absence instead of presence. Sometimes memory appears as a gap, a thinning, a silence in the sky itself. Such was the case with ozone, the unseen shield that drapes across our stratosphere, protecting life from the raw intensity of ultraviolet light. For a moment in recent memory, that shield tore, an unseen hole above Antarctica, where protection vanished into absence. The hole was not visible to the eye, not truly a hole but a thinning, yet it meant that more of the sun's dangerous light reached the surface. The air itself had faltered in its role as guardian. Ozone is a fragile chemistry, 3 atoms of oxygen bound together, delicate against disruption. Formed when ordinary oxygen meets sunlight, destroyed again by other reactions, it is in constant renewal, always balancing itself in the thin stratospheric veil high above. For eons this renewal was steady, ozone forming and breaking in cycles that sustained life, ensuring that DNA could persist beneath the filtered sun. Without this shield, life might never have reached land. Forests might never have stretched upward beneath the sky, our own ancestors might never have emerged from water's sheltering cover. Yet fragile does not mean invulnerable. In the 20th century, something small disturbed the equilibrium. Chlorofluorocarbons, compounds once seen as useful and harmless, rose invisibly into the atmosphere. Stable at the surface, but restless when bombarded by ultraviolet light, they broke apart and released chlorine atoms that devoured ozone molecule by molecule. And slowly, almost quietly, the density of ozone above Antarctica thinned. The stratosphere lost its breath. Ultraviolet light, once filtered, streamed down stronger, scattering across a continent already layered in silence. Penguins, plankton, phytoplankton. Many small lives felt the change directly or indirectly, and though the shift was measurable, subtle, it was profound. A reminder that atmosphere is not an infinite shield but a fragile veil that can be torn by something as trivial as a compound drifting upward from aerosol cans and coolant coils. We found the hole by accident. Scientific instruments detecting ultraviolet fluctuations returned signals that seemed almost implausible, dismissed at first, then proven real beyond doubt. There it was, the atmosphere rewritten, not by volcanoes, not by cosmic fire, but by us. A tear in the quiet blanket of gases, an atmospheric scar. For the first time, we knew we had altered not just the air we breathe, but the air that protects all breaths beneath it. Could it be that this moment was the first true reckoning, that what happens invisible above has consequences too deep to ignore? But ozone is not only fragile, it is resilient in ways we did not expect. Once international agreements stemmed the flow of chlorofluorocarbons, the chemistry began its slow repair. Year after year, the stratosphere healed. The hole has shrunk, though healing is never perfect. Even recovery leaves scars. Even repair is not restoration, but change. Perhaps this is always the way with atmosphere. It does not vanish entirely, but it never returns as it was before. Entropy reshapes even memory of healing, etching faint records in isotopes and in scars of chemistry. And what of us now, living beneath skies that bear this memory of absence? Do we pause beneath sunlight and remember that once the veil thinned, once light grew harsh, once the guardianship faltered? Or has that memory already dissolved into convenience, faded as the crisis itself recedes? Maybe our atmosphere remembers more than we do. The scars of ozone thinning are still written in the stratosphere, in subtle gradients of chemistry, in long-lived compounds that will remain for decades to come. Even healing is not erasure. There is humility in knowing that the sky can be altered so subtly, that 3 atoms of oxygen, fragile in their bond, can determine the flourishing or the fading of life beneath. What is atmosphere, then, but a script written over and over, revised, frayed, sometimes erased, sometimes mended? Perhaps what unsettles us most is realizing how thin it is, how easily torn, how even the act of healing proves how breakable it had been. And so we return to a gentler, lingering question. If even healing leaves marks in air, if scars endure invisibly above, then what other silences in the sky remain hidden, thinnings we have not yet seen, quiet losses carried high above us, waiting to be read like absences in the diary of atmosphere? And if even healing leaves scars in the atmosphere, scars invisible but enduring, then we might ask what scars we ourselves are leaving now. Scars not of ozone or warmth alone, but of memory stretching forward into time we will never see. For perhaps the most haunting question is this: what will the air say of us when we are gone? What traces will linger in this fragile veil, drifting above oceans and mountains, long after our voices have quieted, our buildings toppled, our species faded into silence? Will atmosphere itself become our obituary, written not on paper or stone, but in gases and particles carried endlessly around the globe? We are already inscribing ourselves into it. Every ton of carbon released carries with it not only energy spent, but memory embedded into chemical gradients. Every radionuclide scattered by nuclear tests remains detectable as a marker of our age, a horizon line that future scientists, if there are any, could find and name as ours. Microplastics float into the upper air, fibers of clothing, fragments of packaging, fragments of us. Smog and soot drift across continents, cigarette smoke and industrial haze crossing oceans, binding nations and histories together into a diffuse atmospheric layer, a haze that belongs to no single place but to all. Could it be that this, more than stone monuments or written archives, is our most lasting signature, microscopic shrouds in the wind? The eerie truth is that these traces are inescapable. Even now, our presence is archived in tree rings, in ice cores, in the sediment of remote lakes far removed from cities. Researchers can date our era precisely in ashen isotopes, in the sudden spike of greenhouse gases in air bubbles, in lead deposits, in layers of soot no natural fire ever created. These signals are unmistakable, fundamentally unnatural, undeniable. They are voices in the air that speak even to the future. They were here, not because we intended an inscription, but because we could not exist without leaving one. But what haunts more deeply is imagining who, or what, will ever read this memory. Will a future intelligence drill into ice and crack open bubbles of air that contain our century's trace? A breath of carbon high above background levels, a whisper of gases we scattered carelessly, perhaps molecules of synthetic compounds no natural chemistry can dissolve? Will they wonder at the density of our presence, and the speed with which it came and went? Or will there be no one left to interpret these signals, no being to notice, leaving our atmospheric obituary unspoken, remembered only in ratios and residues drifting unobserved under silence? Consider the possibility that millions of years from now, our species has faded, and yet the planet still holds the air we altered. A coral reef might fossilize with carbon signatures of our industry embedded in its skeleton. A stalactite might grow layer upon layer, still marking the anomalies of warming cycles we triggered. A glacier, if any remain, might seal within it the faint fingerprint of our age, carrying our carbon, our nitrogen, our altered sky. Long after handwriting fades, our air lingers. Perhaps every species leaves memory, but ours may be the first whose memory is chemical, planetary, irreversible. Air may be our most fragile inheritance, but it is also our longest-lived record. It has carried the breaths of mammoths, the cries of birds, the silence of extinctions. It has borne fire and dust, meteors and volcanoes. Now it bears us too, whether we wish it or not. Our breath mingles not only with ancient molecules, but with molecules of our making: CFCs, plastics, radionuclides, exhaust. These are the technofossils of atmosphere, the obituaries of now unfolding already. Not carved into stone but adrift in wind, they remind us that atmosphere is both memory and warning. It saves everything, without judgment, without hierarchy. The innocent exhale of a child, the plume of a factory, the radioactive cloud of an explosion, they are all folded equally into air. Perhaps this is the strangest kind of democracy. All breaths, all exhalations, remembered without distinction. And yet, memory can be more haunting in its longevity than in its precision. Carbon dioxide released today will still shape climate tens of thousands of years from now, lingering long after languages vanish. Synthetic compounds made in recent decades may persist for millennia. The air may someday contain fragments of us still detectable, even if no one remains to breathe it. What if atmosphere's final memory of humanity is not our voices, not our songs, not our dreams, but a chemical imbalance? An obituary not written in words but in entropy, imbalance, and silence. This thought humbles us, for it means the air does not forget, not even when we want it to. It carries everything forward, an endless archive of what was, indifferent to meaning but perfect in its continuity. And so when we breathe, when we exhale into the veil, we are also writing unavoidably. We may think of breath as intimate, immediate, but it is also inheritance for whatever comes next. Maybe long after humanity is gone, each molecule will drift still, a quiet testimony that we once were, that we once breathed, that we once set the sky itself aflame with our presence. And so the question remains, soft but unyielding. If the atmosphere will bear the marks of our civilization long after we dissolve into history, then is air our true monument, the invisible stone, already inscribed, already spoken, waiting for dawns we will never see. And if the atmosphere is already becoming an obituary for us, carrying the chemical traces of our passing into far futures, then it must also be said that we are already living inside that inscription. This age has been given a name whispered between disciplines, a word that feels both scientific and poetic, the Anthropocene. It is the epoch in which human presence cannot be separated from the planet itself. Even the faintest activities, the smallest gestures of consumption or creation, echo now into the atmosphere. Every inhale we take is no longer only a conversation between body and sky, but between nature and industry, between wild breath and manufactured plume. The very chemistry of the air has shifted. Carbon dioxide, once steady in its glacial rhythms, now surges higher than it has in millions of years. Methane joins it, rising steadily, too. Nitrous oxides linger as subtle signatures of agriculture, and the faint scars of ozone depletion remind us of an era when even a single class of chemicals altered the planet's veil. To live in this age is to breathe molecules that did not exist in the same way before, synthetic compounds drifting quietly, long-lived gases with names that feel engineered rather than organic. Could it be that each of us, simply by breathing now, inhales a mixture that has never before existed in Earth's 4-billion-year story? This is not only about presence, but about irreversibility. Plastics that alight into microparticles, mingling in clouds. Soot that coats snow and ice, darkening surfaces so they melt more quickly. Black carbon falling onto glaciers, recording human fire even at the planet's frozen edge. Industry has carried its breath across every border. No mountain range is too high, no desert too barren, no ocean too wide to escape it. In the Anthropocene, air is no longer local. It has become a single shared record of us all. Every campfire, every furnace, every flare is joined invisibly in atmosphere, combined into a chorus too intricate to silence again. And yet, we rarely feel it. The air is invisible, patient, effortless. It fills our lungs no differently than it ever has, and so we forget that we are breathing history. Forget that today's forests are pulsing with cycles bent subtly by our hand, their carbon draw shaped by our choices. Forget that every exhale carries molecules that will mingle with the sky for centuries before finding rest. The Anthropocene atmosphere is ordinary only in appearance. Quiet as it seems, it is already permanent, inscribed irretrievably into the planet's deep memory. There is irony in this realization. For most of history, humanity seemed too small to leave an atmospheric trail. Lightning and volcanoes outshone us. Deserts carried more dust than fires we tended. Oceans absorbed more carbon than our early settlements could ever exhale. And yet, slowly, increment by increment, we tipped the balance. Perhaps the moment came when coal first crackled in furnaces. Or perhaps when oil ignited in engines too numerous to count. Or perhaps when fallout first entered winds, impossible to undo. Maybe there was no single beginning at all, only a gradual shift until we could not separate human breath from planetary breath. And what is most haunting is not only what we release, but what disappears. Forests cut, wetlands drained, oceans acidifying. Each loss strips an atmospheric partner from the air. The voices of those ecosystems are silenced, and their absence too becomes part of the Anthropocene. It is not only an age of presence, but of subtraction. Not because we sought it, but because we lived within it, unaware that each removal was also part of the sky's future archive. And yet, the Anthropocene atmosphere is not without wonder. In it, we see evidence of our vast reach, our entanglement, the inseparability of our story from Earth's. We glimpse that we are not outside nature, never above it, but within it, writing inside its chemistry with every gesture. Every invention folds back into atmosphere. Every spark of fire, every wheel turning, every factory plume becomes part of air's great continuity. The Anthropocene is not only a warning, it is also a mirror, the sky reflecting back all we are, all at once. Perhaps what lingers softly is this: the atmosphere will keep these whispers. Carbon spikes will remain as isotopic scars in ice. Plastics will continue drifting in stratospheric winds. Radionuclides from our brief century of nuclear tests will remain, half-lives outlasting nations, marking calendars no human hand will ever turn. Not because the Earth judges us, but because chemistry does not forget. Every inhale we take, every engine turning, Every cleared field is archived in ratios and residues. Every breath of the Anthropocene is already part of memory greater than ourselves. And so we stand here, breathing air that carries deserts and forests, fire and plastic, atoms from stars, and now molecules we ourselves invented. All of it mingling, inseparable, drifting together as one sky. And if this thin veil of air is both diary and mirror, then what exactly will it say of us? Will it call us architects or accelerants? Will it say we belong to the sky or that we hastened its silence? Maybe, maybe not, but the whispers are already written. And if atmosphere itself is the archive of time, then the next question is almost inevitable. What happens when even the whispers begin to fade and silence expands once more across the sky? And if every breath in this Anthropocene carries whispers of us, folded into ratios and residues that will remain long after we dissolve, then we must turn our imagination towards something more haunting still. What if breath itself ended? Not only human breath, not only the exhalations of animals or the rustle of forests, but breath as a planetary act. Imagine a time when atmosphere itself would no longer move, no longer churn in cycles, no longer whisper through winds or dissolve in rains. A time when the air found stillness, when entropy had reached its final fulfillment, and silence expanded to cover even the very act of breath. Life and atmosphere are entwined. Air circulates because of sunlight unevenly heating seas, because of rotation tugging currents sideways, because forests exchange oxygen for carbon and carbon for oxygen again. Remove imbalance, remove difference, remove participation, and what remains is a sky without motion. It would still exist perhaps, invisible gases suspended above, but without churn, without exchange, without the pulse that gives air its living quality. Could such an atmosphere even be called an atmosphere at all? Or would it be nothing more than a veil of still chemicals, waiting without reason, without negotiation, without time? We know entropy tends all things toward evenness, toward an eventual erasure of gradients, of differences, of imbalance. Heat spreads until it is uniform. Molecules scatter until they are evenly dispersed. The circulation of atmosphere, then, is only a temporary defiance. Winds answering gradients, storms resolving imbalances. But entropy is patient, and its patience is endless. Somewhere immeasurably distant, Earth's winds, too, will tire. The gradients will flatten. The sky will drift into equilibrium so complete that not even clouds will build. Not even rain will fall. Silence expanded not because life ended, but because the air itself forgot how to move. Would Earth remember this end as we remember extinctions, as we remember collapses traced in isotope scars and fossils of vanished seas? Or would it be a forgetting so complete that memory becomes impossible, because atmosphere and memory were always the same thing? Perhaps air is not only a record of life, but life's medium of memory altogether. And in its pause, in its stillness, remembering would also fade. Maybe silence is less about absence than about the final erasure of memory itself. There is something hypnotic about imagining it. Standing within this final air that holds no wind, no breath, one would feel nothing. No rustle of leaves, no cooling breeze, no drift of scent, no rumble of storm. Only stillness, perfect and uninterrupted. The very calm might feel eternal, though it is born from exhaustion, born from nothing left to exchange. Could it be that this stillness is the final entropy, the final obedience to the thermodynamic pull of time? Yet, just as fossils leave stone behind, perhaps silence too would leave its record. Geology has shown us time and again that absence can be as powerful as presence. The disappearance of oxygen once marked the end of ecosystems. The absence of calcium left unbuilt reefs. The disappearance of isotopes has told us as much about epochs as their appearance. If silence ruled air one day, its mark might be equally indelible, a final atmospheric stratum defined not by what remained but by what no longer stirred. This possibility humbles us deeply, for atmosphere has always been alive, always shifting, always responding. It has witnessed and carried everything. Ice advancing, forests burning, comets falling, humans breathing. To imagine its silence is to imagine the end of the only continuity that has bound Earth since its infancy. If silence expands to fill the sky, then Earth itself would inhale no longer, and memory would dissolve into stillness. And yet, even in this imagining, something stirs in us. Could it be that silence itself is not finality, but passage? That when the air grows still, some other medium of remembering remains? Perhaps the rocks, the oceans, or even the stars carry echoes and gradients yet unknown to us. Maybe silence is not the end of memory, but its translation into another form, one we cannot yet perceive. Or maybe it is the final page, and the book itself closes, slipping into darkness without witness. If all things are bound to entropy, then even the most fragile veil of gases must someday find its equilibrium. No storms, no breath, only silence. And so we are led gently, almost inevitably, to the next question. If air itself could become memoryless, stilled into quiet forever, then what hidden movements remain now, marking time across the sky, the vibrations, the echoes, the music of atmosphere we cannot hear, but which may be its last voice before silence expands? And if silence were ever to expand until the atmosphere itself remembered nothing, then perhaps its last testimony would not be words at all, but music. For the air is not still, not truly. Even now, even in its quietest moments, it hums with vibrations we cannot hear, ripples of pressure carried across vast distances, waves that pass invisibly through the body of the sky. The earth is never silent, only pitched beyond our hearing. The air has its hidden music. When thunder rolls across a summer valley, we hear only a fragment of that song. The low rumbling notes dive below our threshold, turning into infrasound, traveling farther, circling the world unnoticed. A single storm may send its signature around the globe, its rhythm faint but persistent, overlapping with other storms, with crashing waves, with the movement of mountains themselves. Imagine the atmosphere as a great drum, vibrated not by human hands but by oceans, winds, and tectonic shifts beneath. Could it be that we live our entire existence inside an orchestra we cannot truly hear? Earthquakes, too, play their movements in the air. When the ground ruptures, sound travels not only through stone but upwards, rippling into the sky. Shockwaves travel outward, lifting into winds, echoing above continents. Volcanic eruptions send their resonance further still. Krakatoa in 1883 rang the atmosphere like a bell, its sound waves circling the planet multiple times, recorded in barometers on the far side of the Earth. If we had instruments fine enough, if we could let hearing stretch beyond its narrow band, perhaps the world would sound ceaseless, a layered harmony of storms, waves, eruptions, and impacts colliding in an invisible chorus. Scientists measure this hidden music with infrasound detectors, barographs, satellite sensors. They find that the planet is restless, that air is always alive with frequencies shifting so low we cannot sense them. The crash of waves on coasts, the jet stream's ceaseless rush, meteors slicing through upper air. Each produces its line in the composition, each writing into atmospheric rhythm. When added together, it is a constant score with no silence, soft, steady, encompassing, as ancient as weather itself. Even living things contribute. The vibration of billions of wings rising with dawn, the resonance of forests whispering as canopies sway, the chorus of migrations moving together through unsettled seas. Though no ear could gather these scales at once, they exist, woven into sound too large and slow for us to recognize. The atmosphere listens forever, even if we cannot. And if we could hear, what would it feel like? Would the pulse of the jet stream be a great bass, steady and endless? Would earthquakes add sudden percussion, low thuds sent racing across the globe? Would the auroras themselves, shimmering in magnetic breath, release tones so soft they are more vibration than sound? Perhaps what we think of as silence is thick with music we are too narrow to perceive. Perhaps noise and silence are illusions born of scale. There is humility in knowing this. We think of ourselves as creatures of music, composers of symphonies, singers of songs, but all we ever do is add to a composition older, vaster, infinite in its patience. Our songs vibrate briefly in air and then dissolve into the greater orchestration. Not because air forgets, but because it carries so much that our notes are only ever small eddies in a boundless current. And still, the music carries further. Lightning cracks, thunder folds, waves crash, winds rise. They blend with frequencies from beyond Earth. Solar winds, geomagnetic storms, cosmic rays, all leave their impression, each one vibrating atmosphere like the brush of fingers against a string. The universe is not soundless either. It continues its own resonance, and Earth's veil of air responds. The hidden hymns of atmosphere are as much the memory of space as of this planet alone. So perhaps when silence finally expands, when equilibrium comes, when the winds stop and breath dissolves, it will not be silence at all. Perhaps it will be the last faint note, stretched too thin for perception, drifting into low frequencies that ripple outward into cosmic distance. And one might wonder gently, as if before sleep, if all of Earth's atmosphere is music, layers of whispers too deep to hear, then what song is playing even now, just beyond us, that we will never recognize until it fades forever? And if the air already hums with hidden music, carrying a vast chorus beyond our hearing, then we cannot help but wonder what melodies are still to come. For as much as atmosphere shapes us, we now hold the possibility of shaping it in return, perhaps more than we ever have before. The question drifts into view like a dawn cloud on the horizon. Might we one day sculpt the very air itself? And if we do, what will the breath of tomorrow remember of us? For much of history, the sky has been beyond our reach, something to accept, to endure, to live within. Winds blew whether we wished them or not. Storms came unbidden. Air remained untouchable. But now, tools of science press against that veil. Engineers speak quietly of methods to cool the earth by design. Mirrors placed in upper air to scatter sunlight. Aerosols released to thicken the sky against heat. Scrubbing technologies to gather carbon from the wind and store it again in stone. Each is speculative, a dream not yet realized. And yet these ideas linger because they hold a certain gravity. If the atmosphere is now altered by us in unintended ways, could we also choose to alter it with intention? Terraforming, too, once the realm of imagination alone, is whispered into possibility. Scientists sketch faint outlines of Mars wrapped in clouds of greenhouse gases. Its air thickened until warmth could return. Venus, though harsher, invites speculation about filters and vast orbital shades, veils constructed to soften its poison atmosphere. Each idea is an echo of a desire not only to survive Earth's changes but to carry atmosphere with us, to sculpt new veils over other planets in our image. Could it be that breath, once so intimate, so unchosen, will one day become a form of craftsmanship, designed as carefully as architecture, sculpted as urgently as fire once was? And yet, what would this mean for memory? For if air is an archive, if every molecule carries history, then engineering it might be less like writing than like erasing, less like memory than like editing. Would tomorrow's air still hold the voices of forests, the traces of extinctions, the whispers of mammoths? Or would they be washed clean, diluted beneath designed atmospheres, hidden beneath clouds we ourselves loft and arrange? Memory might not vanish, but it could be obscured, rewritten into patterns we choose to leave behind. Perhaps one of the strangest legacies of our future could be air that remembers less, or remembers differently, carrying not the voice of Earth alone but the fingerprints of human design. There is beauty in the idea, too, that one day perhaps we might breathe a sky cleaner than it has been in centuries, a world where soot and plastic haze dissolve into silence, drawn away by technologies we invent. To breathe might again feel like inheritance, like gift, untainted by the weight we have given it. And yet the paradox remains, for even a healed sky is still a memory of us, marked by our presence, shaped by our choices. Even if it returns to balance, it returns through our entanglement. Tomorrow's sky cannot escape our reflection, whether in purity or in pollution, whether in silence or in haze. And as our reach extends outward, we may encounter atmospheres alien to us. We may sculpt them not for survival alone, but for imagination. What would it mean to stand on a distant world, to inhale an air that never belonged to Earth, never to a forest or an ocean, but that nonetheless sustains? Would it feel like belonging or trespass, intimacy or exile? Could a new air still carry memory? Or would its silence remind us that we alone had written it from nothing? The thought loops back to humility. Perhaps atmosphere is not ours to sculpt. Perhaps it is not ours to edit. Each time we alter it, we leave traces weightier than we realize. Scars in isotopes, whispers in ice, technofossils adrift. Tomorrow's atmosphere will remember not only what we solved, but what we attempted, what we abandoned, what we left drifting unresolved. Memory is not only held in what succeeds, it is held too in what fails, in the attempts etched into molecules that can never be untangled from their experiments. The breath of tomorrow, then, is not fixed, could be filtered, engineered, stabilized, sculpted, or it could be left scarred, warming further, filled with ghosts of methane and carbon rising unchecked. Perhaps it will be both, engineered in some ways, wounded in others, an atmosphere as ambiguous as we are, carrying contradiction in every layer. Not because the air will choose, but because we already have and will continue to do so. And all the while, the question persists. If we craft skies of tomorrow, whether here or across planets elsewhere, what will they carry of us? Will they remember our care, our restraint, our attempt to preserve continuity? Or will they remember our haste, our insistence on bending all things toward ourselves, leaving scars when silence would have been kinder? Maybe, maybe not. The breath of tomorrow is unwritten, but it is already being composed in every decision we make today. So we breathe, here, in this moment, air that holds jungles and dust, ghosts and whispers, atoms from stars, soot from fires, promise of healing, fear of forgetting. And as we think of tomorrow, we cannot help but ask, when the next breath comes, what will it carry? Will it open into life unimagined, or will it exhale memory of what we could not preserve? Perhaps the atmosphere already knows, waiting only to tell us in ratios and residues too fragile for us to grasp until it is far too late. And if the breath of tomorrow might one day carry signals of our choosing, crafted deliberately as memory or warning, then perhaps it is fitting to circle back to where our wondering first began, with the very first breath, and the recognition that air itself has always been more than invisible background, more than chemistry and pressure, more than protection from the void. Air has been our confidant from the beginning, and perhaps from long before us. In its weightless molecules are threads of stories older than continents, fragments of oceans that no longer exist, whispers drawn from forests now turned to stone. And as each of us inhales, folding that inheritance into our bodies, we cannot help but wonder, what if the air remembers more than we dare to ask? When the earth was young, before it had oceans as we know them, the atmosphere was heavy with gases unfit for breath. Hydrogen, methane, carbon dioxide, water vapor, a turbulent chemistry unkind to life as we imagine it now. But even then, it was alive in its own way, shifting under volcanic plumes, altered by bombardments from beyond, stirred into new compositions by the planet's first restless crust. To call that early veil of gases and atmosphere is to call it memory, because each shift meant a new record, each fluctuation carved into what followed. Even the first cyanobacteria that appeared billions of years later left their legacy not only in stone, but in air itself, gifting oxygen to the sky, forever blending life into atmosphere. It was the Earth's first breath of a new kind, and it set everything we now know into motion. And since then, breath has been continuity. Through epochs of ice and warmth, through silences of extinction and crescendos of flourishing, the atmosphere has kept its archive. Ice cores reveal its precision, layered with bubbles of air that hold fragments of ancient sky. Sediments reveal its patience, holding isotope shifts that recount droughts and floods, turning climatology into a soft translation of memory. Even amber holds it, bubbles sealed for millions of years, small transparent reliquaries of atmospheres we will never breathe again. Every molecule before us has passed through countless forms of life, through lungs of dinosaurs, through the gills of ammonites, through forests buried and reborn. Nothing is lost in air. It lingers, recirculates, disperses, but always returns in some shape. Perhaps this is why it feels intimate, even sacred, to realize that the oxygen we draw tonight might once have belonged to a trilobite, might once have passed in silence through the chest of a mammoth. Breath never begins and never ends, But memory is never perfect continuity. Entropy scatters even breath, spreading molecules wide, dissolving their origins until they are indistinguishable. This is why we cannot point precisely and say, this particle belonged to that creature, that forest, that fire. The details are lost, but the presence remains, stitched into the whole. Perhaps memory in atmosphere is less about precise recall and more about the persistence of essence. What if the air remembers not through clarity, but through accumulation, a chorus of all who have breathed it, every exhale folded invisibly, inseparably into one great continuity? And when we step back and sense the immensity of this, we notice how small our human memories are, how fragile our histories recorded in pages and carvings. The true archive has always been above and around us, traveling on winds, written into isotopes, stored in ice. It has always been speaking, though rarely in ways we could hear. And now, having become both listeners and writers in this ongoing story, we find ourselves poised between humility and awe. Could it be that the oldest and most reliable archive of life has always been the air, that the first breath was also the first page, still unending? Time itself flows differently in atmosphere. The winds you feel on your cheek today were born of sunlight absorbed unevenly by oceans thousands of kilometers away. The oxygen you breathe at dawn may have been made yesterday by a leaf, or millions of years ago by a buried ocean. The carbon exhaled from your lungs may join clouds that circle the earth in days, or seas that keep it for centuries, or rocks that hold it for eons. Every breath is a link across vast chains of time. Inhaling is intimacy not with a moment, but with eternity. Maybe that is why quiet reflection upon breath feels profound. It is never yours alone. It is woven into streams you cannot see, conversations far longer than lifetimes. We may ask, softly, whether atmosphere itself perceives any of this. Not in consciousness as we define it, but in continuity, persistence, symmetry. Life has shaped atmosphere has shaped life, and the two have spoken to one another endlessly, for billions of years. Perhaps this dialogue is its own kind of knowing, one we participate in without awareness. And when the air remembers, it does so not because it intends to, but because every molecule is consequence, every ratio is witness, every silence is telling. Even now, our own presence is folded irreversibly into this continuity. The Anthropocene is evident in carbon dioxide levels written into ice, in synthetic compounds carried on winds and returned in snow, in radionuclides marking a line across the geological record. We cannot walk away unseen. We cannot live without inscription. Breath itself is collaboration with atmosphere, whether we accept it or ignore it. To breathe is to alter, to exhale is to join. And so the memory of air becomes our mirror, one that will outlast us, one that already waits to tell our story long after we disappear. But perhaps the most gentle truth is that the air is not ours at all. It is borrowed, shared, recycled endlessly. We have no claim on it. It passes through us as it has passed through billions before and billions more after. Each inhale is lending, each exhale is gift. In this way, the atmosphere itself seems to whisper the greatest humility into our lives. That we are not beginnings, and we are not ends. We are continuities, contributors to an archive far beyond ourselves. So we return to that first breath, the one that held the world as possibility, the one that seeded memory into molecules, the one that tied chemistry to life. We end where we began, with air as memory, with atmosphere as confidant of deep time. And we ask, with quiet uncertainty, with the gentleness of those nearing sleep, what if the air remembers more than we dare to ask? What if even this moment, this breath, this thought is already woven into eternity, already drifting, already waiting to be recalled not by us, but by the patient memory of sky?